Picture this. On one side of the planet, a scribe in China is writing down that the sun turned blue and yellow, and for days it gave no real light. Thousands of miles away in Rome, a senator is describing something eerily similar. A dimmed sun, an unnatural chill in the air, crops failing when they shouldn't. Meanwhile, in Ireland, monks are recording darkness and famine so severe that people were, in their words, dying from lack of bread. And then, somewhere across the ocean in Mesoamerica, tree rings and ice cores start showing signs of the exact same disruption. Same era, same symptoms. Completely different cultures who had no contact with each other, no shared written language, no way to compare notes across oceans and continents. And yet they're all describing what sounds like the same catastrophe. Not similar disasters. The same one. How is that possible? That's the question we're chasing today. Because when you start pulling together the historical records, from Byzantine chronicles to Chinese court documents, to Mayan inscriptions to oral traditions passed down for generations in Australia and the Pacific, you keep running into the same eerie details over and over again. A sun that stopped giving proper light, skies that turned the wrong colour, floods that didn't behave like normal floods, harvests that failed for years, not seasons, whole societies that seemed to buckle under something bigger than a bad winter or a rough drought. Now, I want to be upfront about something right away. We're not just going to throw a bunch of spooky quotes at you and say, look, ancient people saw the apocalypse, isn't that wild? That's the lazy version of this story, and honestly, it's the version that falls apart the second you poke at it. What we're going to do instead is actually compare the texts side by side, line up the timelines as best they can be lined up, and then check all of it against the physical evidence. Ice cores drilled from Greenland and Antarctica that trap tiny chemical fingerprints of ash and acid from thousands of years ago. Tree rings that record, ring by ring, year by year, exactly how cold or dry a growing season really was. This isn't vibes, this is forensic history, and it gets stranger the deeper you dig. Here's where I have to be honest with you though. Some of these ancient sources are literal, straightforward eyewitness accounts written by people trying to record exactly what they saw. Others are symbolic, wrapped in religious language, omens, and metaphor, the kind of thing that's much harder to pin to an exact date on a calendar. And dates themselves are slippery. Ancient calendars didn't always match up the way we assume. Kings' reigns get miscounted. Monks make copying errors that shift events by years, or even decades. So untangling what actually happened, and when, is part of the mystery too. But that's exactly what makes this so fascinating. Because once you strip away the assumptions and start doing the actual comparison, patterns start to emerge that are very hard to explain away as coincidence. Before we go further, I want to know where you're tuning in from. Drop a comment and tell me your city and what time it is right now for you. I love seeing this. Last time I did this, I had someone in Manila at midnight and someone in Chicago at lunch, both watching the same video at the same moment. It's a small reminder that even now, with all our technology, we're still just scattered humans looking up at the same sky, wondering about the same mysteries our ancestors wondered about too. And if you want to keep exploring stories like this one, the best way to support what I do here is to follow or listen on Spotify. The link is right there in the description. It costs nothing. It helps enormously, and it means more of these deep dives keep getting made. Now let's get into it, because 4 continents apparently saw the same sky fall. And nobody has ever fully explained how. Before we go any further, we need to slow down and ask a question that most people skip completely. What actually counts as the same catastrophe? Because here's the trap. If you go looking hard enough through ancient texts from anywhere on Earth, you will find floods. You will find darkness. You will find fire falling from the sky. These are some of the most common images in human storytelling, period. Every culture that has ever existed has dealt with bad harvests, scary weather, and stories passed down about ancestors who suffered through something terrible. So if all we're doing is collecting scary quotes about darkened skies and calling it evidence of one shared global event, we're not doing history. We're doing pattern matching on easy mode, the kind of thing that feels convincing until someone points out that humans have been telling flood stories since long before any of this happened. So the first job, before we get to a single ancient quote, is building a fair test. What would it actually take to say two civilizations, thousands of miles apart with no contact, were describing the same event, rather than two different disasters that happen to sound similar because disasters tend to sound similar? Let's start with the basic categories of evidence we're working with, because not all ancient sources are created equal, and treating them like they are is where a lot of amateur historical detective work goes wrong. First, you've got chronicles. These are official or semi-official written records, often kept by governments, courts, or religious institutions, meant to document events more or less as they happened. Chinese imperial records fall into this category. Byzantine court histories do too. These sources were often written close to the events they describe, sometimes even by people who witnessed them directly. That makes them valuable, but it doesn't make them perfect. Chroniclers had biases. They wrote to please emperors, to fit religious narratives, to make their own dynasty or kingdom look favoured by heaven. An omen that helps justify a change in leadership might get exaggerated. A famine that embarrasses a ruling class might get downplayed. Chronicles are closer to eyewitness testimony, but eyewitnesses lie, exaggerate, and misunderstand things all the time. Second, you've got myths. This is trickier territory. Myths are cultural stories that carry meaning, morality, and identity, but they're not usually trying to record a specific date the way a chronicle is. A flood myth might be describing an actual regional flood, or it might be a much older story about creation and destruction that has nothing to do with any single event at all. The challenge with myth is that it compresses time. Events that happen generations apart can get merged into a single story. Multiple droughts can become one drought. Multiple floods can become one flood. So myths are useful, sometimes incredibly useful, but they need to be handled carefully, almost like a witness whose memory has been shaped and reshaped by decades of retelling. Third, you've got administrative texts. These aren't dramatic. They're not trying to tell a story at all. They're tax records, agricultural ledgers, court petitions, temple inventories, the boring paperwork of ancient bureaucracies. But boring is exactly what makes them valuable. If a region's tax records suddenly show a massive drop in grain output for several consecutive years, that's not somebody's poetic interpretation of the heavens turning against them. That's a government trying to figure out why it's not getting paid. Administrative texts are some of the most trustworthy evidence we have, precisely because nobody writing them was trying to make a point. And fourth, you've got oral traditions that were eventually written down, sometimes centuries or even 1,000 years after the events they claim to describe. This is where things get both fascinating and genuinely difficult. Oral traditions can preserve real information across an astonishing length of time. Some indigenous Australian oral histories, for example, appear to describe coastline changes from sea level rise that happened over 7,000 years ago, matched up against actual geological evidence. That's a staggering feat of cultural memory. But oral traditions also shift with every generation that retells them. Details get added. Details get lost. Stories from different eras can blend together the way a river absorbs its tributaries. So when we use oral tradition as evidence, we have to treat it the way you'd treat a very old family story, one that's probably rooted in something real, but almost certainly reshaped by everyone who's told it since. Now here's the real danger zone, the part where this entire investigation could go completely off the rails if we're not careful. Floods and darkness are common themes. That's not suspicious on its own. That's just what happens when human beings across the world experience storms, eclipses, wildfires, and seasonal disasters. If every culture on Earth has a flood story, and every culture has some kind of story about darkness or ominous skies, then finding those themes in 4 different places doesn't prove they're describing the same event. It just proves that humans notice water and light. So specificity is everything. General themes don't count. What we need are unusual, oddly matching details, things that shouldn't line up by coincidence. So here's the criteria we're going to hold every single piece of evidence to throughout this investigation. First, multiple independent witnesses. Not one account, not one culture, but separate groups, separate languages, separate belief systems, describing something with enough overlap that coincidence starts to feel unlikely. Second, a tight time window. If 2 events happened 300 years apart, they're not the same catastrophe, no matter how similar they sound. We need accounts that cluster closely enough in time to plausibly be describing one shared global disruption. And third, distinctive physical descriptions. Not generic scary imagery, but specific unusual details. A sun that changes colour in a particular way, a cold that lasts an unusually long time, a famine tied to a very specific kind of crop failure. The more oddly specific the detail, the more it matters when it shows up in 2 unconnected places. Now, timing is where this whole investigation gets genuinely messy, and I want to be upfront about that instead of pretending it's simple. Ancient dating systems were not standardized the way our modern calendar is. Many cultures dated events by regnal years, meaning the 3rd year of this emperor's reign, or the 7th year after that king took the throne. That sounds precise, but it creates huge problems when historians aren't sure exactly when a reign started, or when 2 rival chronicles disagree about how long a ruler actually sat on the throne. A single miscounted regnal year can shift an entire historical event by a decade in either direction. Then there are copying errors. Ancient texts were hand-copied, sometimes centuries after they were originally written, by scribes who occasionally mixed up numbers, skipped lines, or unintentionally merged 2 separate events into one. So when we line up ancient dates, we're not just reading history. We're doing detective work on the history itself, cross-referencing multiple calendar systems, converting lunar calendars to solar ones, and leaning heavily on physical evidence like ice cores and tree rings to anchor these fuzzy human record-keeping systems to something more absolute. Nature, unlike ancient scribes, doesn't misremember a date. So here's how we're going to run this investigation. We're going to look at 4 separate regions of the ancient world, places with no meaningful contact with each other at the time we're examining. Eurasia, stretching from Rome through Byzantium and into China. Africa, particularly the Nile region with its uniquely detailed agricultural and administrative records. The Americas, where tree rings, inscriptions and oral tradition offer a very different kind of evidence trail, and Oceania and Australasia, where oral history stretches back further than almost anywhere else on Earth. If these 4 regions, completely isolated from each other, start describing eerily specific, matching phenomena within a tight window of time, backed up by physical evidence in ice and wood that has no reason to lie, then we're not looking at coincidence anymore. We're looking at something that actually happened, something big enough and strange enough to leave fingerprints on 4 different continents at once. So let's start where the trail is clearest. Let's go back to the skies that apparently went wrong all over the world at almost exactly the same time. When ancient authors start talking about the sky, they don't usually say at approximately 2:17 p.m. solar luminosity declined by 60% due to an increase in stratospheric aerosols. They say things like, the sun lost its strength, or day turned to night, or the heavens were stained with blood, which is poetic and also useless, unless we can sort out what kind of wrong sky they're actually describing. So before we start lining up specific cases, we need a catalogue. What are the strangely consistent sky descriptions that keep showing up in totally different traditions? And what real physical processes could make a sky look that way for more than a few minutes at a time? Over and over again, across centuries and cultures, 4 especially diagnostic patterns show up. First, the dim sun. Not gone, not eclipsed, just weak. Texts that say the sun gave forth its light without brightness, or its rays were like the moon, or that shadows disappeared because there was light, but not enough to throw sharp contrast. Sometimes they mention being able to look straight at the sun without pain. Sometimes they talk about the sun appearing small or shrunken, because without a bright corona, it looks like a pale disk hanging in milk. Second, lingering haze. Not a brief storm, not a passing cloud front, but a mist or smoke or dry fog that hangs on for weeks or months, sometimes, from horizon to horizon. Chroniclers complain that distant mountains vanish. Sailors report that the line between sea and sky blurs. People say the stars are hidden for long stretches, or that only the brightest ones struggle through the murk. Third, unusual colours. Suns and moons described as blood red, copper, saffron, blue-green, ashen, dawn and dusk that stretch out for hours, with fiery or purple or lurid glows that don't match normal sunrise or sunset. Sometimes the text notes multiple colour changes over the course of a day, as if the atmosphere is acting like a prism full of dust. And fourth, persistent twilight, days that never fully brighten, like a world stuck permanently in the last light before night. Midday described as like evening, torches needed at noon to conduct business inside, roosters crowing at strange hours, people complaining that they cannot tell the time by the sun, because the normal cues, the sharpness of shadows and intensity of light, have gone wrong. Those are the kinds of details that start to matter. They're not generic, the gods were angry language. They're weird, physical, testable. So what can actually do that to a sky? At the most basic level, you're looking at stuff between you and the sun, particles, droplets, debris. Change what's floating in the atmosphere, and you change what reaches the ground. Tiny particles in the upper atmosphere, sulfate aerosols from volcanic eruptions, for instance, scatter sunlight very efficiently. They're small enough that they don't just block light like a curtain. They bend and redirect it, especially the shorter wavelengths. That can give you a washed-out bluish or whitish daytime sky, a dim sun, and wildly extended sunrises and sunsets as light passes through a longer column of dusty air. Because those aerosols live in the stratosphere above where it rains, they don't just wash out in a day. They can hang around for months to a couple of years, circling the globe. That's the classic dust veil or dry fog scenario. No obvious smoke smell on the ground, no visible ash falling everywhere, but the light is wrong. People notice that. Bigger particles lower in the atmosphere, desert dust, wildfire smoke, ash, behave differently. They can make dramatic local or regional hazes and blood-red suns near the source. Think dust storms blowing off the Sahara, or entire regions choked with smoke during a bad fire season. Those can last days to weeks, sometimes longer during extended droughts. But they don't usually wrap the entire planet in a uniform veil. They're patchier, more tied to wind patterns, and they often come with other obvious signals. Coughing, ash on surfaces, a heavy smell. Then you've got meteoric debris, a large cometary dust stream or an airburst dumping fine particles high in the atmosphere can produce luminous phenomena, night skies lit with strange glows, increased shooting stars, patches of weird high-altitude haze. But those tend to be either spectacular and brief, like a night or two of intense meteors, or subtle and long-lived in a way that doesn't usually show up as the sun went dim for a whole year in ancient records. You might get a mention of stars falling like rain or fire in the sky, which is its own category, but not sustained daytime gloom. Solar activity belongs in the list too. Intense auroras can spill into latitudes that don't normally see them, turning the night sky red or green, described historically as burning or bloody heavens. People absolutely notice those, but auroras don't dim the sun at noon. They paint the night and maybe the pre-dawn hours, then vanish. They also tend to come in bursts of days, not unbroken months of weirdness. So already we have a basic diagnostic. If a text talks about a brief, spectacular show, stars that flowed like rivers, flaming crosses or dragons in the sky, a single night when the heavens opened like fire, we're probably looking at something like a meteor storm, comet or auroral display. That's a short-lived spectacle. If, on the other hand, the complaint is about a season or a year, when the light was wrong day after day, crops suffered, temperatures dropped, and the sun looked pale or coloured for months, you're in volcanic-style territory, a sustained aerosol veil, or some other long-lived atmospheric loading. Now here's where it gets tricky. Ancient people did not have our vocabulary for aerosols and radiative forcing. They had gods, demons, dragons, heavenly omens, so their sky language is often metaphorical by default. A red sun becomes blood. A dull white disk becomes veiled, sick, wounded. A weird twilight becomes the day mourned. How do you tell when that language is tied to actual observation instead of pure symbolism? You look for constraints. If a text simply says, "The sun turned to blood before a great king fell," that could be an eclipse described in stereotyped language, or it could be an author retrofitting a stock image to make the story punchier. But if the same document adds, "and for many days the land was cold, and the harvest failed," now you're not just in the realm of poetic omen. You're bumping into environmental consequences that don't care about narrative drama. You also check whether the metaphor is embedded in a theological argument, or whether it shows up almost grudgingly in something more matter-of-fact. A sermon that says, "The Lord darkened the sun to show his wrath," is doing theology. A tax document that slashes expected grain yields because, for the whole of the growing season, the sun's light was like the moon, and the fields did not ripen, is doing accounting. When both kinds of texts start describing the same odd sky, that's when the pattern becomes hard to wave away. Seasonality is another key. A single afternoon of darkness in the middle of a clear summer, tied to the moon eating the sun, screams eclipse. People remember the spectacle, and it's over quickly enough that the fields don't care. But texts that talk about an entire summer that felt like autumn, or a winter that never quite ended, with weak sun and late thaw and grain rotting in the stalk, are pointing at a long-duration forcing on the climate. So as we go through examples later, Chinese court astrologers, Byzantine chroniclers, Mesoamerican scribes, oral historians from the Pacific, we're going to keep asking the same question. Are they describing a one-night show or a multi-month dimming? Are the strange colours and darkness tied to specific seasons, especially planting and harvest? Do boring administrative texts quietly back up what the dramatic storytellers are shouting about? Because if 4 different regions start talking about dim suns, lingering haze and wrong season twilight, all inside the same narrow window of time, and their farmers, not just their priests, are complaining about it, then we're no longer just reading metaphors. We're looking at a sky that actually changed, and the next step is to see what the ground did in response. If the first pattern lives in the sky, the second lives in the ground. more specifically in the places where ground stops and water begins. Every culture that lives near a river has flood stories. That's not surprising. Rivers flood. They overtop their banks, rip up fields, knock down houses, drown the unlucky. People tell stories about it. They blame gods, kings, bad omens, whatever fits their worldview. Those stories are important locally, but they're not the ones we're interested in. We're looking for a weirder class of tradition. Flood accounts that don't behave like normal river floods. Stories where something about the timing, the scale, or the kind of water involved feels off if you've ever watched a modern flood on the news. So we need to separate the piles. In the first pile, local river floods. These usually have a recognizable rhythm. They come in a season everyone expects, after the rains, during snowmelt, when the monsoon hits. They're tied to one river or one valley. People say things like, "The river rose higher than anyone had seen," or "The god of the river was angry," or "The dikes broke, and many fields were lost." The water might linger for days, maybe weeks on floodplains, then it goes back down. The town rebuilds in roughly the same place. Life resumes. These stories tend to stay bounded. They don't usually claim the entire world went under. They don't describe the sea charging uphill. They don't talk about salt water killing inland crops. The second pile is different here. You get traditions that insist the sea itself came in. That water rose where it had no right to be, that waves overtopped cliffs that had never seen spray, that the boundary between land and ocean moved suddenly and violently, not over millennia, but in what sounds like a single day or a single night. When you start reading across cultures, the details that pop up again and again are surprisingly specific. Timing, for one. Many of these stories pin the flood, not to a rainy season, but to a clear day or to a time when the river should have been low. They say things like, "There were no clouds, yet the sea climbed the land," or "Without rain the waters rose." That rules out the usual too much precipitation scenario and points you towards something else. Duration is another flag. Normal river floods often last as long as the input does. Days of heavy rain, weeks of snowmelt. But lots of these sea came-in accounts describe a short, brutal hit. Water arriving in minutes, hours at most, then pulling back. People talk about a single giant wave, or a series of waves over the same day, not a month of slowly expanding puddles. Saltwater intrusion shows up too. That's a fancy way of saying the wrong kind of water shows up in the wrong place. Some traditions complain that wells turned brackish, that the soil near the coast died, that previously sweet lagoons became undrinkable. Fishermen lose their usual species as estuaries are rearranged. Farmers talk about whole tracts of land becoming useless because the sea poisoned it. Then there's the debris. Modern tsunami photos show an almost unbelievable mess. Boats sitting on rooftops inland, boulders rolled into towns, trees jammed into bridges at strange angles. Ancient storytellers didn't have drone footage, but they noticed the same kind of chaos. You see lines like, "Great stones were thrown upon the plain. The boats lay far from the shore among the houses. Trees were snapped and carried as if they were grass." That is not your typical overbank river flood slowly rising up the street. And finally, mass displacement. Of course, any bad flood can make people move. But some accounts talk about whole communities abandoning their old coastal sites entirely. The old village lies under the waves. We went to live with the people of the hills and never returned. Our ancestors crossed the mountains after the sea took their land. That permanent relocation signal matters because it implies that the shoreline itself changed. So what physical mechanisms can do these different things? On one end you've got classic hydrological floods, extreme precipitation, snowmelt, maybe a river channel blocked by a landslide or ice dam. They're powerful, but they tend to be tied to weather patterns and drainage basins. They rise and fall with the river, and they're usually fresh water. Then there are glacial lake outburst floods. During and after ice ages, giant lakes form behind ice dams. When those fail, you don't get a gently rising river. You get walls of water hundreds of feet high ripping through valleys at highway speeds. They can scour landscapes, move house-sized boulders, erase soil. Indigenous traditions in some parts of the world almost certainly remember this kind of event. But these are usually inland phenomena. They can feed big river floods downstream. Not necessarily the sea came in stories. For that, you look to the coast, tsunamis and storm surges. Tsunamis, whether from seafloor earthquakes, underwater landslides or impacts, move entire columns of water. They're not just tall waves breaking at the beach, they're long, fast bulges that keep going far inland, lifting harbours, snapping ships from moorings, then draining back and stripping everything loose. You get that abrupt onset, the multiple waves, the weird behaviour of water, receding unrealistically far before crashing back. You get salty water far inland. You get those insane debris fields. Storm surges are different, but to a villager on the coast, they can look just as apocalyptic. A massive cyclone can pile up the ocean, pushing it onto land at the same time. Heavy rain is dumping from above. Combine low pressure, strong onshore winds and a high tide, and the sea level at a coast can jump by several meters. That's enough to drown low-lying areas in hours. The water might hang around longer than in a tsunami, especially where drainage is poor, and it will be salty. Now layer on one more idea: landscape memory. A flood can move a boulder. A story can move a boulder's meaning. When a shoreline gets hit by a once-in-a-thousand-years event, the land itself can preserve the scar, washed in sand layers in a coastal swamp, stranded boulder fields, chewed-up river terraces. People who live there walk past those scars every day. They teach their kids, don't build too close to that line of stones. The sea once reached here. That warning becomes a myth, then a ritual, then a story about a god's anger or a hero saving a remnant of people. You end up with oral traditions that are weirdly accurate about which hills stayed dry, which inlets were dangerous, how far inland the water once came. That's not random. That's practical geology wrapped in narrative. And this is where cross-continental parallels get interesting. If coastal societies on different continents all have not just there was once a great flood, but the sea ran uphill on a clear day. The salt killed the fields, the boats lay on the land. We left the old coast and never went back. You start wondering whether they're each encoding some version of the same class of event. Rare, high-energy coastal inundations tied to something bigger than local rain. Because some of the candidates we'll look at later, mega-tsunamis from landslides or impacts, volcanic eruptions that collapse islands, even certain extreme storm clusters, can do two things at once. They can throw dust or sulfates into the sky, giving you dim suns and wrong-coloured dawns, and they can shove water onto land in a way that coastal people never forget. So, as we move into specific case files, keep those two questions running in the background. Is this flood story just a river doing what rivers do? Or is it the sea doing something it almost never does? And when a culture talks about a darkened sun, and, in the same rough window, a day when the ocean climbed the earth, are we maybe seeing two different angles on one physical catastrophe? If the second pattern lives where land meets water, the third lives in something even more basic. Food, or more precisely, the sudden, terrifying moment when food stops behaving the way it's supposed to. Once you've seen enough pre-modern chronicles, you start to recognize famine on the page even when nobody uses the word famine. because they almost never start with, "In this year there was a famine." They start with symptoms. Prices move first. You'll see a calm analyst who's been listing births of princes and repairs of bridges for 20 pages suddenly write, "In the third month, a measure of grain cost 10 times the usual rate," or "the poor could not approach the markets," or "people sold their tools, their land, even their children, for food." That's a famine marker. You see rationing too, but it's not called that. It's framed as moral decay or desperate improvisation. Families mixed bark with flour. They ground acorns and reeds to make bread. The government opened the granaries, but the stores were quickly exhausted. Officials start regulating who can buy grain and how much. That's a signal that normal supply has broken. Then movement begins. Chroniclers start talking about bands of beggars on the roads, multitudes wandering in search of sustenance, villages empty, their people gone. Sometimes it's framed as piety, pilgrimages, going to famous temples to beg the gods for rain. Sometimes it's framed as crime. Robbers increased in the countryside, soldiers deserted and lived by plunder. Underneath the moralizing, you're seeing displacement, people leaving places that can't feed them and heading anywhere. And then there's abandonment. You'll read lines like, "Many fields lay untilled. The outer hamlets fell to ruin. No one remained in the low villages. The hills alone were inhabited." Archaeologically, you might see it as a layer of trash and then nothing. No rebuild, no next phase. Textually, it's a throwaway sentence about deserted settlements. Put together, it's a food system that stopped being able to hold people in place. What ties this to our catastrophe pattern is when these social symptoms line up with very specific environmental complaints. Climate-sensitive clues. Farmers in every pre-industrial society are experts in their own micro-weather. They know when the snow should melt, when the river should swell, when the first green shoots should appear. So when their calendars fail them, they notice. You see notes like "snow fell in the 6th month," when it has no business doing that. "Ice on the river at harvest time." The blossoms were killed by frost. The summer was cold and wet, the grain blackened on the stalk. Or the reverse in some regions. No snow in the months of snow, the ground bare and dry. Both are bad. Both wreck the carefully tuned timing of planting and harvest. Growing seasons shrink. Instead of "the wheat sprouted and ripened," you get "the wheat sprouted but did not fill. The ears were empty, the grapes were small and sour." That's agronomy in narrative form. Crops that start growing but never get enough warmth, light, or time to mature. It doesn't take a volcanic textbook to decode that. It takes a farmer saying, "We sowed on time. The year betrayed us." Sometimes the language gets almost poetic. Cold seized the summer. The rains were out of season. There was no proper heat. If the darkness and red suns of the first pattern tell you about the sky, these lines tell you about the ground's response. Now, different kinds of writers notice different parts of this collapse. Court chroniclers like numbers and order. They record decrees. In this year, taxes on grain were remitted. The emperor commanded porridge kitchens. Border guards were told to admit refugees. The tone is administrative. Famine appears as a problem of logistics and control. Priests frame the same reality in moral and ritual terms. They write, "The gods turned their faces away. Omens were seen, sacrifices were increased, fasts were proclaimed." You hear about processions with holy images carried through parched fields or snow-covered vineyards. The crops have failed, but the focus is, which deity did we offend and how do we fix it? Poets and storytellers go for visceral detail. You get lines about people eating the flesh of beasts unclean, mothers sharing a single handful of grain among many children, the dead unburied in the streets. Some of these accounts are exaggerated to shock, some are raw memory. Either way, they capture the emotional texture, not just hunger, but the breaking of social norms around food. All of these perspectives are biased. Rulers want to look competent, priests want the gods to stay central, poets want drama. But when they all independently start circling the same cluster of details, failed harvests, strange cold or heat, food prices exploding, people on the move, that's when you know you're not looking at a single bad storm or a lazy governor. You're seeing agricultural collapse. It's tempting to draw a straight arrow from bad harvest to regime falls. Reality is messier. Plenty of states survive horrendous famines. Some even come out stronger because they centralize control, crush rivals, and win loyalty by feeding their core supporters. But crop failure is almost always an accelerant. If the tax system was already brittle, if armies were expensive, if elites were fighting over succession, a year or two of missing grain can push everything sideways. Soldiers go unpaid and start looting. Border provinces, already resentful, stop forwarding surplus to the capital. Local magnates hoard supplies and suddenly look more attractive than distant kings. Chroniclers describe this as rebellions, bandit uprisings, the loss of heaven's mandate, the king's heart grown weak. Underneath you often find the same baseline: too many mouths, not enough calories, for long enough that patience runs out. So when we talk about a year without summer pattern, we're not just chasing weather trivia. We're asking, are there windows where very different societies, on different continents, all start telling the same kind of story at the same time? Strange cold, mistimed seasons, harvests that never ripen, followed by price spikes, rationing, migrations, and political stress. And here's where we step out of the texts and into the mud, the ice and the wood. Because climate doesn't just write in chronicles, it writes in tree rings where narrow bands mark cold or dry years. It writes in ice cores where layers of trapped bubbles and dust and sulfuric acid record volcanic clouds and atmospheric chemistry. It writes in lake sediments where pollen grains and algae and charcoal settle year after year, telling you what was growing, what was burning, and how clear the water was. In a bit, we're going to start lining those physical records up with the human ones. We'll look at whether the cold summers and empty fields in the text sync with spikes of volcanic sulfate in Greenland ice, with sudden growth-stunted rings in European or Asian trees, with layers of unusual deposits in lakes. Because if a scribe in Constantinople, a monk in Ireland, a bureaucrat in China, and an oral historian in the Andes all talk about the year the crops failed under a cold, dim sun, and the planet's own archives show a sharp, global climate jolt in the exact same slice of time, that's not just a sad story about hunger. That's a signal that something big hit the whole food system at once. So let's open one specific case file. If you ask climate historians, give me one moment when people in wildly different places all complained that the sky itself went wrong, most of them will slide the same folder across the table. The 530s and 540s, not as a neat, single event we fully understand, but as a disturbed window where text after text starts muttering about a sun that wouldn't behave, and seasons that stopped making sense. Start in the Mediterranean, because that's where the story usually gets told first. A Syriac chronicler, writing about the year we'd call 536, notes that the sun's light was without brightness, like the moon, and that this went on for more than a year. Procopius, a court historian in Constantinople, calmly records that the sun gave forth its light without brightness, like the moon during the whole year, and that men were free neither from war nor pestilence, nor any other thing that brings death. Another source says there was a great and terrible sign in the heavens, a dim, pale sun, and a strange dry fog. The language is different, biblical, bureaucratic, apocalyptic, but the complaint is the same. Daylight dimmed, The sun looked wrong, move northwest into Latin Christendom. Later Irish annals, compiling older notations, talk about a failure of bread and cold summers around this time. One entry mentions a great mortality, another a mysterious darkness and bad weather in the mid-530s. Scholars argue about how much of this is retrofitted Christian rhetoric, but buried under the piety you see the markers we just talked about: harvest failure, hunger, weird seasons. Byzantine and Near Eastern sources add another layer: snow and frost out of season. Reports of heavy snowfall in places that rarely see it. Complaints that trees failed to blossom in their month, that vines did not ripen, that winter and summer were alike. The sort of thing farmers would only bother to write down if it scared them. Now jump east. In Chinese chronicles, the same rough stretch of years brings reports of yellow dust in the air, dimmer sunlight, and unusual cold and drought in some regions. One text describes frost in the 6th month. Another notes that the sun was bluish and that harvests were poor. Korean records echo some of this: strange mists, failed crops, people on the move. These aren't word-for-word copies of Procopius. The cosmologies, political systems, even the calendar frameworks are different. But in a loose band from the eastern Atlantic to East Asia, within a couple of decades, you see a family of complaints: a veiled sun, discoloured light, off-kilter seasons, and the food systems buckling underneath. This is why the mid-6th century has become a favourite suspect when people go hunting for shared catastrophe moments. You've got multiple regions across Eurasia all talking about atmospheric weirdness, not just local storms. A cluster of famine and plague narratives, including the famous Justinianic plague, showing up on the heels of those sky reports. And, as we'll see later, physical archives, ice cores, tree rings, that appear to show sharp climatic jolts right in that window. But before we decide we've caught our culprit, we have to look hard at the evidence we're actually holding, because we're not reading live tweets from 536. We're reading copies of manuscripts filtered through scribes, monks and scholars whose goals were not accurate climate reporting. Most of these sources are annals and chronicles, terse year-by-year notes, later stitched together into smoother narratives. Many are retrospective. An Irish monk in the 9th century might be copying a 7th century list, which itself condensed oral memory of a bad decade. A Chinese historian might insert strange sky reports to underline that a dynasty had lost heaven's favour. A Syriac chronicler might lean into biblical language, darkened sun, ominous signs, because that's how you frame disaster in his world. Rhetoric matters here in Christian and Buddhist contexts. Famine and plague are moral lessons. In Confucian contexts, they're political judgments on rulers. In apocalyptic circles, they're end times previews. So a metaphor like the sun refused to shine might be poetic exaggeration, or it might be somebody trying to describe a very real attenuation of daylight with the only toolkit they have. There's also copying and cross-pollination to worry about inside Eurasia itself. Stories travel along trade routes. A dramatic description from Constantinople could echo in Syriac church histories. A Chinese omen catalogue could shape how later writers describe any unusual weather. Historians have caught direct borrowing in some of these texts, phrases, motifs, even whole passages reusing earlier disaster tropes. So when we put all these accounts side by side, we have to keep two separate questions in our heads. Are they narratively similar, because the same story is echoing from book to book? Or are they similar because different people, in different languages, were struggling to describe the same underlying physical shock? That's where the dust veil idea comes in. Modern researchers coin that term to describe what you'd get if one or more huge volcanic eruptions blasted fine particles and sulfur into the stratosphere. Not thick, choking ash at ground level. That usually stays regional, but a high, thin, planet-girdling veil of aerosols that scatters sunlight. From below, the world doesn't go pitch black. It goes wrong. The sun looks pale, reddish or bluish. Shadows soften. The sky can stay hazy for months. Less energy reaches the surface. Summers run cold. Growing seasons compress. Monsoons and storm tracks can shift. In especially bad cases, you stack one eruption on top of another before the atmosphere is cleared and the cooling compounds. Within that framework, the mid-6th century starts to look like a textbook, if brutal case study, multiple Eurasian observers complaining about dim light and weird colours in the sky, followed by years of poor harvests and social stress. Ice core data, which we'll get to, suggests at least 2 very large eruptions, probably in 535-5, 136, and again around 540, plus possible smaller ones. Climate feedbacks then prolong and spread the chill. But starts to look like is not solved. Chronicles don't give us coordinates of volcanoes. They don't tell us whether these were 1 or 2 truly gigantic blasts, a cascade of medium-sized eruptions, or some mixture swirling with natural climate variability. They almost completely ignore regions outside their own cultural horizons. A monk in Gaul doesn't tell you what was happening in the Sahel or the Andes, and that's crucial for this series, because right now our dust veil story is mostly a Eurasian story written in Eurasian sources, with physical records heavily weighted toward the Northern Hemisphere. It's a strong candidate window for a shared catastrophe, but it's still just that, a candidate. If this really was a planet-scale disruption, if people across 4, maybe 5 continents were all seeing the sky go strange and the harvests fail, then the trail shouldn't stop at the edge of the Roman Empire or the Chinese court. It should show up in the ice chemistry from both poles. It should show up in tree rings outside Europe and Asia. It should echo, however faintly, in African chronicles, in American oral traditions, in Pacific stories about years when the world cooled or the sea behaved badly. So the next move is obvious. We take this mid-6th century dust veil file, the dimmed suns, the cold summers, the famine and plague, and we walk it over to the planet's physical archives. Ice, wood, sediment. Then we ask a harder question. Does anything outside Eurasia sing the same tune at the same time? If you want to know whether the sky itself really changed, you don't start with the stories. You start with the ice. Every year in Greenland and Antarctica, fresh snow falls, gets buried, and compresses into ice. Layer by layer, year by year, those ice sheets quietly record what was floating in the air above them. Not just dust and pollen, but the fallout from forest fires, industrial pollution, and volcanic eruptions. Drill down through that ice, bring up a long cylinder, and you're basically unrolling the atmosphere's old diary. At low resolution you see stripes, darker layers for dusty years, cleaner layers for quieter ones. At high resolution, with modern instruments, you can read the chemistry of individual seasons. You can measure sulfate concentrations, tiny acid spikes that appear when sulfur dioxide from volcanoes gets turned into sulfuric acid droplets in the stratosphere and then rains out onto polar snow. Those sulfate spikes are the first big clue. Under normal conditions, background sulfate levels in the ice are modest and wobbly. Then a really large eruption happens somewhere on Earth, blasts sulfur high enough to spread globally, and a year or 2 later that snow layer lights up in the core. Sulfate levels shoot way above baseline. If both Greenland and Antarctica show a sharp spike around the same time, odds are you're looking at a volcano that affected the whole planet, not just one hemisphere. Sometimes you get more than chemistry, you get grit. Mixed in with those layers, scientists occasionally find microscopic bits of volcanic glass, tephra. These shards are not random. When magma explodes into the air and cools, it freezes in a way that reflects the composition of the lava. Silica content, trace elements, crystal structure, together they form a kind of forensic fingerprint. So researchers melt down sections of ice, filter out the particles, put them under microscopes, and use techniques like electron microprobe analysis to read that composition. Then they compare it to known tephra from specific volcanoes, Icelandic systems like Elja or Katla, tropical monsters like Krakatoa or Tambora, Alaskan and Kamchatkan volcanoes, and so on. When the fingerprints match, you suddenly have more than a big eruption happened. You have this particular volcano blew up around this time, and we can see its fingerprints in the polar ice. That's the ideal scenario. Big sulfate spike, clear tephra, matched to a known suspect. Reality is messier. Tephra doesn't fall evenly around the world. The coarser particles drop out close to the volcano. The really fine stuff can make it to the poles, but not always in quantities big enough to recover. Some eruptions are rich in sulfur, but poor in glass shards. Others blast enormous ash, but relatively little sulfur into the stratosphere, so they may darken skies regionally without leaving a huge sulfate signal in the ice. On top of that, the dating isn't perfect. Ice cores are dated by counting annual layers, like tree rings, but those layers get thinner and more distorted with depth. In the upper sections, we can line up individual years with high confidence. Deeper down or during stormy periods where snow accumulation was irregular, the count can drift. One core might place a spike in 535, another in 536, a third in mid-530s with a plus-minus error bar of several years. So when historians point to a sulfate spike in 536, what they really mean is, somewhere in that narrow band, depending on which core, which counting method, and which corrections you use. It's close enough to compare with texts, but not precise enough to say, Procopius saw this exact eruption sky. Then there's the problem of missing or blended signals. If two sizable eruptions go off within a decade, their sulfate plumes can partially overlap in the ice record, especially in lower resolution cores. What looks like one fat, smeared-out spike might actually be 2 or 3 distinct events, a tropical blast, then a high-latitude eruption, then another moderate one a few years later. From a climate perspective, that sequence matters a lot. The first eruption sends sulfur into the stratosphere, cutting incoming sunlight and cooling the surface. The climate system starts to respond. Less evaporation, weakened monsoons, altered jet streams. Before the atmosphere fully clears, usually after 1 to 3 years, a second eruption adds more aerosols on top of an already perturbed system. Cooling deepens. Growing seasons shrink for multiple years in a row. Sea ice expands. Weather patterns shift in ways no farmer has seen in living memory. From the point of view of people on the ground, it's one long, uncanny stretch where the sun won't shine right, and the years are out of joint. They're not going to say, yes, clearly we are experiencing 3 separate volcanic forcing pulses with partial stratospheric residence time overlap. They're going to remember it as the time the sky went wrong and the harvests failed. A string of eruptions becomes in human memory a single mega-event. This is where we can start to align the physical record with the language of the Chronicles. A strong, sulfur-rich eruption that puts aerosols into the stratosphere tends to dim direct sunlight without turning day into night. People talk about the sun looking pale, bluish, like the moon, or without its usual brightness. Change colours at sunrise and sunset. Scattering in a hazy sky makes reds deeper, halos more common. You see mentions of blood-red suns, strange rings, unusual glows. Produce a persistent, dry haze. Not a choking ash storm, but a high veil that makes distant mountains fade and stars fewer at night. Texts describe a mist, fog, or smoke that doesn't smell like fire and doesn't clear with the wind. Cool summers more than winters. Chronicles notice frost in months that should be warm, crops that do not ripen, years without summer, vines that fail. Those are classic aerosol-driven patterns. When multiple regions using different religious and literary traditions start using that same cluster of images, dim, wrong-coloured sun, long-lasting haze, failed summers, within the same rough decade, and the ice cores show clustered sulfate spikes in that window, the match becomes hard to dismiss as coincidence. But we still have to be cautious. An ice core spike tells you that sulfur hit the stratosphere. It doesn't by itself tell you how bright the sun looked in Ireland, or whether Ethiopian rains failed, or what a Maya skywatcher thought he saw. The chemistry is global. The human experience is regional. So the next step is to cross-examine the ice with another independent witness, the trees. Because if the sky really dimmed worldwide, plants should have noticed and left their own record of stunted, cold or chaotic growing seasons, ring by ring, far beyond the reach of Roman scribes and Chinese court historians. Trees don't write chronicles, but they do keep receipts. Every year, a tree in a temperate climate does something incredibly helpful for future nosy humans. It lays down one growth ring. In a good year, plenty of warmth, enough moisture, long growing season, that ring is relatively thick. The tree had energy to spare. In a bad year, late frost, cold summer, drought stress, it tightens its belt. The ring is narrow, wood cells are smaller, growth is stunted. Dendrochronology is the science of reading that pattern. Take a long-lived tree like a bristlecone pine in the western United States or an old oak in Europe. Slice a cross-section, or more often, gently core it with a hollow drill that doesn't kill the tree. Under magnification, you can count the rings back in time, one by one, like ticking off birthdays. The trick is not just counting, but matching. Trees of the same species growing in the same region respond in similar ways to the same climate shocks. A brutally cold, wet summer around the year 536, say, will produce a conspicuous set of narrow rings in many trees at once. Younger trees that weren't alive in 536 still experienced, say, a similar shock in 622, and their ring pattern for that decade will line up with the pattern in older trees for that interval. By overlapping these patterns across many individuals, scientists build a continuous, exactly dated chronology that can run back thousands of years. Once that calendar is nailed down, you can do the forensic work. Which years are conspicuously bad? Under normal conditions you expect ups and downs, somewhat good years, somewhat bad years. Trees are living things, not thermometers. But then you hit a cluster of years where growth crashes across whole regions, extremely narrow rings, sometimes even frost rings, where a sudden cold snap damages the wood as it's forming. Those are the botanical equivalents of bold red ink. They say something hit the growing season hard. Often that something is a combination of temperature and moisture stress. A year that's cool but nicely moist might not be catastrophic. A year that's hot but wet can still produce decent growth. But a year that's both cool and dry, or a year where spring starts normally and then summer suddenly turns frigid, will hammer trees. They can't photosynthesize at full speed under those conditions. They make do, they survive, but they barely grow. This is where the tree rings start talking to the ice cores. Take one of those sulfate spikes in the polar record, dated, allowing for those small uncertainties to the mid-530s. Now look at tree ring chronologies from Europe, Siberia, North America, even parts of Asia. Independent teams using different species start finding the same pattern, an abrupt run of exceptionally narrow rings right after the sulfate spike window, signalling a couple of deeply abnormal summers. Some trees show damage from late frosts well into the growing season. Others show a multi-year slump. Growth picks up slightly after the first hit, then gets knocked down again, as if the climate tried to recover and then was forced back into stress. On paper, this looks exactly like what you'd expect from a stratospheric aerosol veil: reduced sunlight, cooled land surfaces, shorter and more erratic growing seasons, possibly weakened monsoons. But here's where it gets interesting and where it complicates the story. The tree record isn't uniform, it's lopsided. High-latitude trees in the northern hemisphere often show the clearest, sharpest signals from these suspected volcanic episodes. Scandinavian pines, Siberian larches, North American conifers in the Rockies. They respond strongly to changes in summer temperature because their growing season is already short. Knock a few critical degrees off July and August, and their annual growth crashes. Move closer to the equator, or into regions where moisture is a bigger limiting factor than temperature, and the signal can blur. A volcanic eruption that cools the globe by 0.5 degree on average might not produce a neatly dramatic ring in a tree whose main problem is, will it rain at all this season? In some tropical or subtropical regions, the same eruption might even bring extra rain, slightly cooler but wetter conditions that trees actually like. This is where the idea of teleconnections comes in. The climate system is not a simple dimmer switch where you just turn down the sun and every region gets proportionally colder. It's a tangled machine of ocean currents, jet streams, monsoon circulations, and pressure patterns. Disturb it in one place, and the ripple propagates along invisible lines of connection. A big tropical eruption, for example, can cool the planet on average, but also shift where the ITCZ, the tropical rain belt, sits. It can nudge the position and strength of the polar jet stream. Monsoons that usually drench India or the Sahel might weaken or change timing. Storm tracks that normally bring rain to the Mediterranean or China might migrate north or south. For farmers, that translates into weird, inconsistent years. One region might get crushing drought, another, far away, might get relentless rain and cold. Both experience failed harvests, but for opposite reasons. The trees in those places faithfully record the local version of the disturbance. Narrow rings from drought here, narrow rings from chill and cloud there. The global driver is the same, but the local story is different. This is why one hemisphere can seem to light up more than the other in the tree ring data. Northern mid and high latitudes are heavily sampled and highly sensitive to summer temperature. Southern hemisphere land, especially with long-lived trees suitable for precise dating, is rarer and patchier in the record. An eruption whose aerosol cloud spreads more strongly in the north will leave a big dendrochronological footprint there, but a much subtler one in the south. So what happens when you line these tree ring chronologies up next to human accounts? Things start to click. You see, for instance, that the year without summer style descriptions in European sources align with a plunge in ring widths in European oaks and Scandinavian pines. Chinese annals that complain of frosts and crop failures in particular years match downturns in East Asian tree chronologies. When Irish annals talk about failure of bread over multiple seasons, you see an extended period of stressed growth in local trees, not just a single bad harvest. The trees don't care about politics, religion, or literary style. They're not trying to dramatize God's wrath or flatter an emperor. They're just responding to how much energy they can capture from the sun, how much water they can pull from the soil, and how long the growing season lasts. When their ring patterns and the narratives written by terrified humans both shout, something was wrong with the summers, at roughly the same time, confidence that we're dealing with a real environmental shock goes up. But we have to respect the limits, A tree ring tells you about conditions in the few meters of air and soil immediately around that tree. It's hyperlocal. A forest of narrow rings in northern Europe doesn't automatically mean the same thing was happening in West Africa or Peru. To talk about global impacts, scientists stitch together many local records from different regions and species, and they cross-check them with other proxies: ice cores, lake sediments, coral growth, glacier advances. Even then, interpretation is tricky. Narrow rings can come from volcanic cooling, but also from ordinary climate variability, persistent droughts, insect outbreaks, or repeated fires. You need context. Is the anomaly synchronized across continents? Does it align with independent evidence of volcanic aerosols? Are there matching signals in historical documents, in glacier length records, in lake levels? When all of those pieces line up, ice chemistry, tree rings, chronicles, even archaeological signs of sudden stress on societies, you start to glimpse not just a bad harvest, but the fingerprint of a climate system that's been kicked hard. And that's where the global catastrophe question gets sharper. Because the trees can show you which regions actually lived through shortened, colder or otherwise bizarre growing seasons. At the same time, the written sources are talking about years without summer and heavens that did not give their light. Next we have to ask, did everyone share that experience? Or were some continents living through a deep climate shock, while others were hit by something else entirely, droughts, floods, or disruptions that don't neatly match the volcanic cooling story? To answer that, we need to leave the forests of Europe and Asia, and look at places where written records are rarer, but the stakes were just as high, starting with the Nile, and the societies that depended on its rhythm. If you're trying to spot a global catastrophe in Africa, you don't open a medieval chronicle and expect to find, on this year, the stratospheric aerosol load increased dramatically. You look for rivers that stopped behaving. In North and East Africa, climate doesn't just show up as it was cold the way it does in Europe or China. It shows up as the Nile not rising high enough, as the flood failing, as caravans not arriving because the water holes along the route dried out, as kings suddenly remitting taxes, or grain prices spiking so violently that scribes felt compelled to write it down. That's one big reason African evidence looks different. The societies that left written traces in late antiquity and the early medieval period were often keyed to hydrology, not to thermometer-style summers. The Nile, in particular, was a climate sensor with a bureaucracy attached. For ancient and medieval Egypt, the annual inundation was everything. Each summer snowmelt and monsoon rains in the Ethiopian highlands, and the Great Lakes region fed the Blue Nile and its tributaries. Weeks later, the river in Egypt would swell, overtop its banks, and spread nutrient-rich silt across the floodplain. If the flood was right, not too high, not too low, you got bumper harvests. If it was low, irrigation basins stayed dry, fields went unwatered, and the food system collapsed a year or two down the line. Nile-dependent states built political theology on that cycle. Pharaohs, Ptolemies, Roman prefects, caliphs. They all staked legitimacy on Maat, on order, which included the river showing up on schedule. When it didn't, it wasn't just inconvenient weather. It was a cosmic warning sign. So scribes watched the flood. In later periods, especially under the early Islamic Caliphate, we actually have semi-systematic notes of good and bad Nile years. Chroniclers mention specific seasons when the flood was disastrously low, leading to famine in Egypt and food shortages downstream in the wider Mediterranean grain economy. You see phrases like "the Nile failed," followed by stories of people eating refuse, governors begging for relief shipments, tax registers being rewritten because there simply wasn't any surplus to take. Those Nile failure years are prime suspects when we're hunting for global disruptions. Because the Nile isn't a local rain-fed stream, it's an integrated readout of a huge region's climate, Ethiopian monsoon strength, East African rainfall, equatorial lake storage. If something tampers with the monsoon system over that whole zone, the signal arrives in Egypt as a shallow river. This is where the teleconnection idea from before comes back, but with a twist. Large volcanic eruptions or major shifts in solar output can nudge the tropical circulation belts. They can weaken or displace the African and Indian monsoons. In climate models, big northern hemisphere eruptions often produce precisely the kind of pattern that would hurt Nile floods. Slightly cooler land surfaces relative to the ocean, altered pressure gradients, a monsoon that starts late, rains that fall in the wrong place, or not enough of them reaching the Ethiopian highlands. From the point of view of a farmer near Thebes, that doesn't look like global forcing. It looks like the river betrayed us, and it's not just the Nile. Step out into the Sahel and the Horn of Africa, and societies are keyed to the pulse of seasonal rains, not snowmelt. Here, prolonged drought, 2, 3, 5 bad rainy seasons in a row, is the climate catastrophe that gets preserved in memory. It shows up in later Arabic chronicles as years of dryness, in Ethiopian royal annals as times when locusts and famine stalked the land, in oral traditions as epochs when cattle died and people were forced to move. These records are patchy. We don't have continuous year-by-year diaries from the 6th century Sahel. What we do have are scattered clues, mentions of abandoned wells, accounts of caravans changing their routes, hints that kingdoms rose or fell during periods modern lake sediment cores flag as unusually arid. Which brings us to a key problem. African sources are both crucial and fragile. Papyrus doesn't love humidity. Termites adore palm leaf manuscripts. Political upheavals erase archives. Many of the texts we do have, Coptic histories, Arabic geographers, Ethiopian chronicles, were copied and recopied centuries after the events they describe. Dates shift. Omens get embellished. Later scribes reinterpret earlier disasters through their own theological lenses. There's also a brutal regional bias. Egypt, the Nubian kingdoms, the Ethiopian highlands, the Arabic-speaking cities along the Red Sea and North African coast. These places plug into larger literate networks, so their crises are more likely to be mentioned, sometimes even by outsiders. Huge swaths of West, Central and Southern Africa, meanwhile, were primarily oral cultures in this era. Their catastrophe stories survive, if at all, as mythic fragments collected much later, ripped from their original time anchors. That means we have to be cautious. When a medieval Arabic historian remarks that the Nile failed for several consecutive years and that famine gripped Egypt, we can't automatically declare global volcanic winter. The flood could have been knocked off by internal climate variability, by regional decadal oscillations that have nothing to do with a one-off eruption. The same goes for drought traditions in the Horn of Africa or the Sahel. So researchers reach for independent witnesses that don't care about scribal habits, lakes, mud and chemistry. Around the Nile basin and across East Africa, long-lived lakes, Tana, Turkana, Victoria, Tanganyika, quietly record water balance in their sediments. High stands leave one kind of layer, low stands another. Changes in the mix of microfossils in grain size, in certain isotopes of oxygen and carbon, all tell you whether a given period was relatively wet or dry. Some of these lake records show abrupt drops in level or shifts toward drier conditions that line up. Within dating uncertainties, with known global volcanic events, and with reported Nile failures or Ethiopian famines. In a few cases, cores from different lakes, hundreds of kilometers apart, point to the same multi-year drought episode. That's when ears perk up, because now you have a Nile crisis in the texts, and a basin scale drying in the mud, both hinting that the monsoon itself was disturbed. But those cores also underline the gaps. Dating lake layers to a specific calendar year is much harder than counting tree rings. Radiocarbon ages come with error bars, turbid events smear time. A mid-6th century drought in one core might actually sit a couple of decades off from another record. That fuzziness is exactly where overconfident stories about perfectly synchronized global catastrophes get into trouble. Still, when you zoom out, a picture starts to flicker. Africa doesn't show up as a clean, continuous climate log the way some European or Chinese sources do. It appears in flashes: a failed Nile here, a remembered rainless time there, a sediment core that screams lake levels crashed, an ivory trade route that suddenly shifts north or south. None of these, taken alone, prove a global event. But when they roughly coincide with ice core sulfate spikes, tree ring cold summers, and Eurasian chronicles complaining about darkened suns, they stop looking like random bad years and start looking like Africa's angle on the same planetary disturbance. The challenge and the invitation is to read those angles without forcing them into a neat narrative they can't support. Because if Africa was indeed feeling the same shock as Europe and Asia, it likely felt it differently, not as snow in summer, but as rivers that failed their promise and rains that never came. And if our global catastrophe really did leave fingerprints on the Nile and the East African monsoons, then the next place to look is where another continent's rivers, skies, and stories might have recorded their own version of the same event. Across the Atlantic, in the Americas. When you cross the Atlantic, your tools change again. You don't get a 6th century bureaucrat in Teotihuacan noting visibility reduced due to stratospheric aerosols. You get myths told to Spanish friars 1,000 years later. You get Maya codices that mostly didn't survive the bonfires. You get archaeological layers of ash, charcoal and bones with no little note pinned to them saying, "This was the bad summer when the sun went wrong." So the American record is more like a palimpsest, later ink written over older stories, fragments of sky omens, darkness, hunger and upheaval, preserved in languages that were already fighting against extinction by the time anyone started asking, "Hey, did your ancestors ever talk about a year when the sun didn't behave?" That makes the Americas tricky, but not blank. One of the most important moves here is to treat indigenous traditions as what they are. Not newspaper clippings, not fantasy novels, but memory systems. For millennia, people from the Andes to the Arctic carried history in stories, songs, ritual cycles, and place names. Those media don't store information the way an archive does. They compress, symbolize, and reframe it. A drought that starved your great-grandparents doesn't survive for 800 years as it rained 40% less than average between June and August. It survives as the sky serpent withheld its waters, or the sun turned its face from the people. A meteor airburst isn't a bolide exploded at 30 kilometers altitude. It's the sky cracked and fire fell. An unusually dim reddish sun seen through months of smoke becomes the wounded sun, or the sun eaten by a jaguar, or the day went dark at midday. Those are mythic phrases, but mythic language can still be wrapped around real events. Ethnographers working with native communities have documented cases where oral histories line up with independent geological evidence. Tsunami stories in the Pacific Northwest that match Cascadia megathrust earthquakes, flood myths in the Amazon that echo Paleolake outbursts, volcanic legends in Mesoamerica that fit eruption dates within a few generations. The same storytelling machinery that makes room for gods and monsters also preserves the sequence, the sign in the sky, the shaking, the wave, the hunger. So when we go looking for darkness traditions in the Americas, we're not expecting to read AD 536 in a codex. We're asking a narrower question: are there clusters of stories, from different cultures that point to sky anomalies and ecological shock in roughly the right window. What turns up is suggestive, but you have to hold it with open hands. There are Mesoamerican narratives about suns that failed, worlds that ended in darkness, and previous ages destroyed by catastrophe. Some of these are clearly cosmological grand cycles, not calendar years, but some mention more specific sequences, a time when the sun was weak, when crops failed, when people turned to desperate measures. In the Andes there are traditions about years of ash and black snow from volcanoes, about skies so clouded that people could stare at the sun. In the North American plains and southwest, you get stories of fire falling from the sky, of summers out of joint, of game vanishing. None of those by themselves prove a mid-6th century dust veil. They could record local eruptions, regional fires, or older events entirely. But when you lay them next to the physical record, they start to rhyme with other clues. Across parts of the Americas, the archaeological layers around the 6th and 7th centuries show stress. In some regions, large settlements shrink or are abruptly abandoned. Agricultural terraces fall out of use. Pollen records in lake mud shift, indicating changes in what people were growing or what could even survive. Isotopes in buried bones suggest diets tipping toward famine foods, more wild plants and small animals, fewer domesticated staples. Charcoal counts in sediments spike in certain basins, hinting at widespread burning, either because fires were more frequent or because landscapes dried enough that a single spark could race across kilometers. In some areas you see a rise in fortifications, palisades and defensive positioning of villages. Projectile points become more common in certain sites. That usually signals conflict, or at least heightened fear of it. Now, could all of this be tied to local climate wiggles? Absolutely. The Americas are climate patchy. El Niño Southern Oscillation, shifts in the intertropical convergence zone, Atlantic and Pacific sea surface temperature changes, these can hammer one region while leaving another relatively untouched. A drought that devastates maize farmers in Mesoamerica might barely register in the eastern woodlands. And that's exactly why methodological humility matters here. You can take the same pattern, stories of darkened skies, archaeological evidence of burning and crop failure, signs of conflict, and fit different scripts to it. One researcher might argue for a big volcanic eruption in the tropics, throwing a sulfur veil over both hemispheres, weakening monsoons and provoking fires from Mexico to Patagonia. Another might focus on a run of bad El Niño years, drying out forests and grasslands, or on a regional mega-drought recorded in tree rings from North America. A third might point to meteor phenomena. We know the Earth is constantly bombarded by small objects. Most burn up harmlessly, but a larger airburst, like Tunguska in 1908, can flatten forests, ignite fires, and produce spectacular sky displays, glowing dust trains, halos around the sun, nights that stay weirdly bright. Oral traditions about stars that became suns, or fire that moved across the sky and did not return, could easily encode those encounters, even if they were isolated to one region. The hard part is not letting one striking story dominate the others. If you decide ahead of time that every sun-eaten myth is about the same global catastrophe, you'll force-fit the evidence until it agrees with you. If you refuse to consider that any of them might be anchored to actual, datable events, you'll throw away information those communities carefully carried across generations. A more careful approach does something in between. It lines up the oral accounts, the archaeological disruptions, the charcoal and pollen and isotopes, and then asks, where do multiple independent lines hint at the same kind of shock in roughly the same slice of time across widely separated regions? Where do the stories of strange skies coincide with layers of ash or soot, with abrupt dietary shifts, with settlement moves up or down slope? Those intersection points won't shout global, they'll whisper at least regional, maybe bigger. And when they appear near the same decades that ice cores in Greenland and Antarctica show big sulfate spikes, and Eurasian chronicles complain about the sun losing its strength, that's when the Americas stop feeling like a blank map and start feeling like another angle on the same disturbance. But to really test that, we have to widen the lens one more time. Because if a planetary scale event really did darken skies and twist climates from Europe to Africa to the Americas, the oceans in between wouldn't have been silent bystanders. Out in the Pacific and around Australasia, whole cultures built their histories around the behaviour of the sea itself, its level, its moods, its willingness to stay where it belongs. And some of their oldest stories talk about a time when the ocean didn't. If you grow up on a tiny atoll where the highest point is a clump of bushes 3 meters above high tide, you do not treat the ocean as background scenery. It is the main character. For a lot of Pacific cultures, the deep existential threat is not the harvest failed or the river dried up. It's the sea moved. The line between land and water is supposed to be a covenant. The reef breaks the waves. The lagoon stays calm. The beach stays roughly where your grandmother remembers it. So, when that line fails, when the sea suddenly climbs the land, tears houses apart, and does not entirely go back, that burns into memory in a particular way. Across Oceania and Australasia, you see this in the structure of tradition. There are stories about storms and bad seasons, sure. But the stories that get locked into ritual, into chant, into the names of places and the rules about where you are not allowed to live anymore, are often tsunami stories. They're not labelled tsunami, obviously. They go more like the sea came in. The old village went under. The ancestors moved to the hill. A reef becomes the place where the wave stood. A headland becomes where the water turned back. Sometimes the name is bluntly practical. Do not sleep here. Sometimes it's encoded in a myth about angered spirits or broken taboos. The moral varies. The geography doesn't. Ethnographers working in Aotearoa, New Zealand, for example, have documented Maori traditions that describe waves running far inland, drowning entire kainga, forcing hapu to resettle on higher terraces. Those stories line up eerily well with geological traces of pre-contact tsunamis, sand sheets laid down over soils, marine shells dumped in what should be dry paddocks. On Australia's north and east coasts, Aboriginal communities preserve narratives about the sea rushing in and the old ground out there, pointing offshore and describing land that is now drowned shelf. Some of those look like deep-time memories of gradual post-Ice Age sea level rise, telescoped into a few human generations. Others sound more like single disastrous pulses, a big wave, a night of chaos, then a new shoreline. The way these events are timed is very different from how a chronicle works. You don't get, in the 7th year of so-and-so a wave struck. You get genealogy. The disaster is pegged to the time of our ancestor X, or 4 chiefs before the present one, or when the canoe of Y landed. In some Polynesian lineages you can count back named generations, 20, 30, 40, each linked to a remembered event, a migration, a war, a famine, an ash fall, a great wave. That doesn't give you a precise calendar date, but it does tell you something crucial. This isn't vague mythic antiquity. This happened within the remembered chain of people whose descendants are still here. And that makes tsunamis unusually sticky in oral history. They get tied to who moved where, who lost which piece of land, who gained the right to fish a new reef. The story is woven into land tenure and identity, which gives it strong reasons to be repeated accurately. But not every remembered wave is a world-spanning disaster, and this is where we have to slow down. Most tsunamis are local or regional. A big subduction zone earthquake off Sumatra, Tonga, Japan, or the Aleutians can send walls of water across an ocean basin, killing tens of thousands and rewriting coastlines. Those are monumental, but they are still tectonic events. Plates slip, water is displaced, waves radiate. Some researchers have proposed rarer, nastier players, impact-generated mega-tsunamis from asteroids or comet fragments slamming into the ocean. In those scenarios, you can in principle get kilometre-scale waves near the impact, basin-wide devastation, and run-ups that dwarf anything in the historical tsunami record. If even one such event had happened in the last few thousand years, you would expect the Pacific to be full of stories about it. What we actually see so far looks more like a patchwork of different events. Some islander traditions can be plausibly linked to specific earthquakes we know about from geology and Japanese or European records. Others match older tsunamis inferred from sand layers tucked inland behind dunes in places like New Zealand, the Solomons and northwestern Australia. Still others are probably memories of storm surges or cyclones, terrifying, destructive, but meteorological rather than seismic. To test which is which, scientists have turned to corals and dirt. Coral microatolls, those flat-topped coral pancakes that grow in very shallow water, record sea level history in their skeletons. Their upper surface is set by the lowest tide they can survive. If a big earthquake or subsidence event drops the land, the microatoll suddenly finds itself deeper and its growth pattern changes. By dating those shifts, you can reconstruct when coasts abruptly moved relative to the sea. Coastal stratigraphy, the layer cake of sands, silts and soils in beach ridges and back swamps, holds the other half of the story. A tsunami leaves a distinctive fingerprint, a sheet of sand with marine microfossils laid over terrestrial soil, sometimes with rip-up clasts and a sharp boundary, sometimes nested in sequences that show multiple waves. Put the two together and you can say, at roughly this time, the land jolted and the sea ran inland X meters, and then you can go back to the oral record and ask whether anyone's stories or genealogies cluster around that date. So far, these methods have confirmed that many Pacific and Australasian communities were not just telling stories, they were carrying calibrated memories of specific sea incursions, sometimes for many centuries. But here's the question that matters for our larger mystery. Can a sky catastrophe and an ocean catastrophe ever be the same chain? In principle, yes. A big undersea eruption sends gas and ash into the stratosphere and waves across the ocean. A major impact into water throws both spray and dust into the air. From the shore that could look like a sequence. Strange things in the sky, days or weeks of odd light. Then, maybe after a lull, the day the sea came in. If something like that had happened in the mid-6th century, you'd expect to see three things. Ice cores with the chemistry of a colossal eruption or impact, tree rings showing cooling, and in tsunami-prone regions, sand sheets and oral histories pointing to a great wave, not obviously tied to a known fault. Pieces of that exist, but they're not clean. The ice and trees are screaming volcano cluster, not single impact. The tsunami layers in the Pacific don't all date to the same decade. The genealogical clocks don't neatly point to 536. Which brings us back to uncertainty. Oceania and Australasia show that humans are capable of remembering physical catastrophes, huge waves, drowned land, sudden shoreline shifts, for an impressively long time without writing anything down. They also show that there are many ways for coasts to be wrecked. Earthquakes, slides, storms, possibly even cosmic splashes. To claim that one global-scale sky disaster produced a single, globally remembered ocean disaster, you'd need those independent clocks, ice, trees, corals, sands, stories, to all tick at once. Right now, they don't. But the fact that they almost can is what keeps this puzzle alive. If volcanic ash in Greenland can rhyme with famine in Europe and weird summers in China, it's not crazy to ask whether some future core, micro-atoll or story will finally link a darkened sky to a wandering sea. To get there, though, we have to look up again, from waves to plumes, from shorelines to shock fronts, and ask what kind of event can dim the sun, cool the world, and still leave so many different fingerprints. When you strip it down to physics, volcanoes are almost boringly straightforward killers. They don't have to fling lava across continents or bury cities in ash to change the world. All they really have to do is cough the right gases high enough into the sky. When a big eruption punches through the tropopause into the stratosphere, it's not the ash that does the long-term work. The ash falls out in days to weeks. The real player is sulfur. Volcanoes vent sulfur dioxide. Up in the stratosphere, that gas reacts with water vapor and oxidants to form tiny droplets of sulfuric acid, sulfate aerosols. Think of them as a thin haze of microscopic mirrors wrapped around the planet. They don't care what country is underneath. They sit above the weather, scattering and reflecting incoming sunlight back into space. Less energy reaches the surface. The ground cools. The oceans cool. The whole climate machine starts running a little slower. But cooling is only half the story. Change the amount of sunlight hitting different latitudes, and you start tugging on the pressure belts and wind patterns that steer storms. The monsoon weakens or shifts. Some regions get hammered with extra rain. Others watch their usual wet season simply not arrive. After Tambora erupted in 1815, sulfate aerosols spread around the globe. In Europe and North America, 1816 became the year without a summer. Frosts in June, snow in August, failed harvests, famine. In India and China, monsoon failures and crop disasters followed. That's one eruption. Now imagine not one, but a drumbeat. A big tropical volcano goes off. The stratosphere fills with sulfate. Global temperatures dip for a year or two, rain belts wobble. Before that veil has fully settled out, before the atmosphere has had time to clear, a second volcano erupts. Maybe it's in the other hemisphere, maybe it's another tropical giant. Another load of sulfur joins the first. Each individual aerosol cloud lingers for a couple of years. If you space eruptions a few years or a decade apart, their effects can overlap. Instead of a single cold summer, you get a decade of mostly bad summers. Not a one-off failed harvest, but a generation that grows up thinking, the weather has gone wrong. This is exactly what some ice cores are hinting at in the mid-6th century. Not one clean spike of volcanic sulfur, but a cluster. Multiple eruptions, some possibly enormous, layered close together. Tree ring records from Europe, Asia, and the Americas echo the same pattern. Narrow rings, stunted growth, summer temperatures knocked down again and again. Translate that physics into lived experience, and the pattern from the Chronicles starts to make sense. If you're a farmer or a monk or a court astrologer, you don't see sulfate aerosol optical depth anomalies. You see a sun that looks weak, like it's shining through dirty glass. You see sunsets that go lurid red and purple. At midday the light feels wrong, muted, hazy, sometimes with a pale whitish disk instead of a fierce gold one. Your summer comes in late and leaves early. Frosts nip the seedlings. Rain that should fall gently over months arrives in wild bursts, or not at all. Rivers that used to flood predictably misbehave, too much, too little at the wrong time. Grain fails to fill. Fruit rots on the branch. Livestock die because there's nothing to feed them. Put that across 4 continents, and you get exactly the language we keep seeing. The sun was darkened, the air was corrupted, Cold and hunger afflicted the people. The sky showed signs. In traditions that don't keep year-by-year records, these become the years the sun changed, the time of the bitter summers. So volcanic theory is very, very good at explaining sky weirdness plus food system collapse. Where it starts to wobble is water disasters with no obvious meteorological trigger. Sulfate-driven cooling can shift storm tracks and intensify some flood seasons. You can absolutely get atypical floods and droughts as the monsoon stutters and the jet stream kinks. But a classic earthquake-style tsunami, that's a different mechanism. You need seafloor to move, or a huge mass to fall into the ocean. Undersea eruptions can, in principle, do both: blow a caldera apart, cause flank collapses, push water. A very large volcanic edifice failing into the sea can launch sizable waves. But tying a global dim sun veil cleanly to one specific the sea came in story on the far side of an ocean requires a chain of coincidence. The right volcano, the right geometry, the right timing. Volcanoes also struggle with sudden one-off inland deluges that legends sometimes describe as the whole world drowned in a single night. You can get heavier rains and freak storms in a perturbed climate, yes. Whether that maps to the most dramatic flood traditions is still debatable. So if we take cluster of eruptions seriously as hypothesis A, what would move it from plausible to probable? On the physical side, we'd want ice cores from both hemispheres that show synchronized sulfur spikes in the target window with chemical fingerprints, isotopes, trace metals that match known volcanic provinces. Tree ring records on multiple continents that line up with those spikes, showing not just generic cooling but the same sequence of bad years and partial recoveries you'd expect from overlapping aerosol veils. Sediment cores from lakes and oceans that capture abrupt shifts in dust, pollen and erosion, signals of landscape stress and altered rainfall in the right decades. If undersea eruptions are part of the story, tsunami deposits or subsidence signals that can be securely dated to the same narrow window and tied to volcanic sources, not just faults. On the human side, we'd look for independent written accounts in different calendrical systems that can be cross-dated and allude to similar atmospheric anomalies and harvest failures within a few years of each other. Oral traditions that, when anchored by archaeology or genetics, cluster their wrong sun or cold years around those same centuries, rather than being smeared vaguely across time. What would weaken the volcanic veil idea? If future high-resolution ice cores broke the 6th century cluster into small local eruptions, each too weak to explain global patterns, that would be a problem. If precise dating showed that the most dramatic darkness reports on different continents actually lobbed past each other by half a century, that would be another. If the biggest ecological shocks in tree rings or corals clearly preceded or lagged the sulfur peaks by many decades, we'd have to look elsewhere. Right now, though, volcanoes still sit in pole position. They're the one mechanism we know can dim the sun across the globe, shove climate around for years, and leave the chemical equivalent of a signed confession in the ice. But they might not be acting alone. And once you start asking what else could throw dust and light into chaos on a planetary scale, you inevitably look up higher than any plume can reach. If volcanoes are the slow, smouldering assassins of the climate system, space rocks are the snipers. They don't care about your tectonic plates. They don't wait for magma chambers to pressurize. They arrive whenever celestial mechanics says they will at tens of kilometers per second, and they turn kinetic energy into heat and shock in a fraction of a second. But space rock disaster is not one thing. It matters enormously what actually happens. An airburst is when a comet or asteroid comes in fast, hits the thick part of the atmosphere, and disintegrates before ever touching the ground. All that momentum turns into a fireball and a shockwave. Think Tunguska in 1908, Trees flattened over 2,000 square kilometers, no crater. Now scale that up or move it over a populated, literate world. A land impact is different. That's when a big enough chunk survives the plunge and slams into rock. You get a crater. Excavated material blasted skyward, melt glass, shockwaves that can level cities out to regional scales, and a plume of dust and vaporized stone that can, if it's large enough, reach the stratosphere or even higher. An ocean impact sits somewhere between the two with its own twist. Most of the planet is water. Statistically, more big impacts will hit the sea than land. If a solid object hits deep ocean at high speed, you get a different energy partition. Less crater in rock, more displaced water, potentially large tsunamis, and a column of seawater and vapour blown upward, dragging dissolved salts and seafloor sediment with it. Each of these has a different human eyewitness mode. An airburst gives you a blazing object streaking across the sky, sometimes breaking into multiple pieces. There's blinding light, maybe brighter than the sun for a second or two, and then delayed thunder that doesn't sound like thunder, sharp detonations, rolling booms, windows shattering, buildings rattling. Shockwaves can knock people off their feet, tear roofs off, flatten forests. Nights afterward might feel uncanny. Glowing dust trains, strange luminescence in the upper atmosphere, reports of two suns or burning stars that hung in the sky. A big land impact adds fire. The immediate blast can ignite forests and grasslands. You'd see mountains of flame, the ground leaping, stones falling from the sky. If the plume punches high enough, the fine dust and aerosols can spread globally in dim sunlight, almost like a rapid onset volcanic veil, but potentially richer in pulverized rock than sulfate. An ocean strike gives you spectacle in the sky, plus walls of water. First the flash and the roar, then, depending on where you are relative to the impact, the sea pulls back in an eerie, unnatural way, or it just rises as a line on the horizon that keeps getting taller. Coastal peoples remember those as the sea climbed the land. The ocean came to live among the trees. The water ate the villages in a single visit. On the scientific side, we don't just go hunting for dramatic stories. We look for impact proxies, physical fingerprints that say, something from space hit here, rather than this was just a bad storm. Iridium anomalies are one. Iridium is rare in the Earth's crust, but relatively common in many meteorites. When a large impact vaporizes and distributes extraterrestrial material, you can see a thin layer in sediments where iridium concentrations suddenly spike. Microspherules are another. When rock is flash melted and sprayed into the air, it can cool into tiny glassy beads that rain back down and get trapped in lake muds, ocean cores and soils. Under a microscope, they have characteristic shapes and compositions. Then there are shocked minerals, quartz grains and other crystals that have been deformed in ways that require immense, instantaneous pressure. Normal tectonic squeezing can't do it. Shocked quartz at a particular horizon in sediments is a smoking gun for a major blast. For ocean impacts that generate tsunamis, we also look for tsunami deposits, odd layers of coarse sand and marine shells washed far inland, draped over soils that used to be dry land, sometimes interbedded with human artifacts. If you can date those layers and line them up with other impact proxies, you start to get a case. But start to get a case is the key phrase here, because a comet hit the Earth and caused global darkness is an extraordinary claim. It needs more than one type of evidence pointing in the same direction. You want multiple proxies: iridium, microspherules, shocked minerals, tsunami deposits, maybe even tree ring scars from sudden heating, all converging on the same narrow band of years. You want that physical layer to show up in different places on different continents with consistent dates. Without that, It's dangerously easy to let the drama of impact physics fill in gaps that the data doesn't actually close. A single local airburst can flatten a region and traumatize its survivors into telling flood and fire legends for millennia. That does not automatically mean the whole planet went dark. And then there's the timing problem. Impacts are by nature abrupt. The main energy release happens in seconds to minutes. The human experience of the blast, the wave, the firestorm, hours, maybe days, that fits the most one terrible night or morning when the sky opened, stories eerily well. But can a brief event also produce a long volcanic-style cooling? Sometimes, yes, but with caveats. A sufficiently large land or shallow sea impact that excavates lots of fine material can loft dust and sulfate-bearing rock high into the atmosphere, that can in principle create a global dust veil that lingers for months to a few years, dimming the sun and knocking temperatures down, very similar at first glance to a big eruption. The details matter. Impact dust may settle faster, or interact differently with clouds than volcanic sulfate. The chemical fingerprint in ice cores would be different. Less volcanic sulfur, more meteoritic elements and pulverized crustal material. So if our mid-6th century wrong sun and failed summers were driven by an impact, we'd expect to see a sharp, well-dated layer in ice cores rich in extraterrestrial markers, not just sulfur, a closely timed layer in sediments with microspherules and shocked minerals. Possibly tsunami deposits along vulnerable coasts, and tree ring evidence of sudden trauma, fire, blast, at some locations, followed by several cool years. So far, the volcanic cluster hypothesis fits the ice and tree data more straightforwardly than any single known impact does. That doesn't rule out a space rock contribution, but it means impact scenarios have a higher evidentiary bar to clear. Until that multi-proxy pattern shows up cleanly in the physical record, comets and asteroids sit in the intriguing but unproven column, a reminder that the sky can hurt us in spectacular ways, but not yet a locked-in explanation for why 4 continents remembered the light going wrong at the same time. If impactors are snipers, the sun is more like an angry, occasionally drunk landlord. It's there every day. It pays the energy bills for the entire biosphere. And most of the time it's boringly stable, but every so often it throws a fit. When the sun gets restless, it doesn't throw rocks. It throws charged particles and magnetic chaos. We call them solar flares and coronal mass ejections, CMEs. Enormous bubbles of magnetized plasma ripped off the solar surface and hurled outward at hundreds to thousands of kilometers per second. Most of those miss us. Space is big. But when one hits square on, Earth's magnetic field and upper atmosphere light up. Under normal conditions, all of that drama is mostly confined to the poles. Charged particles spiral down magnetic field lines, slam into oxygen and nitrogen high in the atmosphere, and you get the auroras, curtains of green and red lights, shimmering and pulsing across Arctic and Antarctic skies. During extreme solar storms, that auroral oval doesn't stay politely at high latitudes. It swells. It can push down over Europe, over the continental United States, over China and the Mediterranean. Suddenly, places that never see the northern lights find their entire sky rippling with ghostly colour. Historical records of strong geomagnetic storms read like mythology. In 1859, during the Carrington event, people in the Caribbean could read newspapers at midnight by auroral light. Telegraph systems, shocked operators, caught fire and ran on their own with no batteries connected. In the American West, miners stumbled out of their camps for breakfast because they thought it was dawn. The sky was that bright. Earlier Chinese, European and Middle Eastern chronicles talk about blood-red vapours, fiery lances, armies in the heavens, serpents and dragons of light writhing across the sky. Some mention the whole north on fire, ghostly banners, red clouds that moved against the wind. If you'd never seen an aurora before, if your entire life had taught you that the sky is a stable blue dome by day and a black, star-spattered lid at night, what vocabulary would you even have? You'd probably grab the scariest words you could find. Fire, dragons, swords, seas of blood. The sky burned from horizon to horizon. The firmament opened and armies appeared. A red river flowed above the earth. From a physicist's perspective, it's just electrons and protons, magnetic field lines, and excited oxygen atoms emitting specific wavelengths of light. From a shepherd's perspective in the 7th century, it's the end of the world. Auroras don't just glow peacefully either. They flicker. They pulsate. They brighten and dim in seconds. They can form arches that stretch from one horizon to the other, or vertical columns that look like pillars. They can be greenish, whitish, or, under certain conditions, a deep, unsettling crimson that stains the entire night sky. Add in other solar effects, unusual halos around the sun, bright sundogs, false suns refracted by ice crystals during dusty or hazy conditions, and you get a sensory package that is almost tailor-made to be misread as the heavens are breaking. So could an extreme solar storm explain some of those wrong sky, blood sun, armies above the clouds traditions that show up far from the usual auroral zones? Absolutely, at least for the visual part. A Carrington scale or larger event would push auroras deep into the tropics. Multiple continents could see it within the same night. People would remember. But here's where we have to be clear about what the sun can't do, or at least is not known to do, on human timescales. A geomagnetic superstorm by itself doesn't throw dust into the stratosphere. It doesn't blanket the planet in sulfate aerosols. It doesn't block sunlight for years. Your crops don't fail in China because electrons hit the ionosphere over Norway. Modern worries about solar storms are mostly technological. They can fry power grids, damage satellites, knock out radio communication, confuse navigation, and maybe in extreme cases lead to a blackout decade if transformers are destroyed faster than we can replace them. They do not, on their own, give you a year without summer. So if we're trying to explain multi-year cooling, persistent crop failures, and tree rings that record multiple bad growing seasons in a row, a pure the sun went crazy scenario doesn't fit well. It gives us the night sky spectacle. It doesn't give us the long volcanic style dimming that pushes us toward hybrid scenarios. Imagine this sequence. A big volcanic eruption or cluster of eruptions throws a veil of aerosols into the stratosphere. Days are dimmer. Sunrises and sunsets become unnaturally vivid, deep reds and purples painted across a hazy sky. People are already nervous. The sun looks weak, sick, blood-coloured. Now in the middle of those anxious years, an extreme solar storm hits. The already dust and aerosol-filled atmosphere scatters and refracts the auroral light in complicated ways. Nights turn lurid, red glows, veils, sheets that don't look like the normal auroras even where people might have seen them before. Near tropical societies that have no auroral tradition suddenly see the heavens igniting above their fields. If you're living through failed harvests and cold summers, and then the sky literally turns red and starts to move, you don't separate volcano physics from space weather. You experience a single fused event. The world is ending and the sky is testifying. From an investigator's perspective, that fused experience is a nightmare. The stories blend phenomena with very different physical causes into one omen-rich memory. So how do we test whether solar extremes were really in the mix? We can't dig up a fossil aurora, but we can look for the sun's fingerprints in isotopes. Extreme solar storms, especially if tied to changes in solar activity over decades, can alter the flux of high-energy particles reaching the upper atmosphere. That in turn tweaks the production rates of cosmogenic isotopes, rare atoms made when cosmic rays smash into nitrogen and oxygen. Two of the most useful are carbon-14 and beryllium-10. Trees lock in carbon-14 year by year as they grow, recording tiny changes in atmospheric levels in their rings. Polar ice traps beryllium-10 in annual layers of snowfall. If there's a sudden spike in production, a cosmic ray event, you can sometimes see a sharp, globally synchronized bump in those records. We've already identified some of these in the last few millennia. The so-called Miyake events around 775 CE and 994 CE show up as abrupt carbon-14 increases in tree rings all over the world, likely linked to extreme solar activity or related cosmic phenomena. So if a big mapped catastrophe century lines up with a distinct cosmogenic isotope spike, that strengthens the case that something weird from the sun was part of the story. If, on the other hand, we see strong volcanic sulfate signals in ice cores, but no corresponding carbon-14 or beryllium-10 anomaly, then a purely solar explanation looks weaker. The real test is convergence. Do we see, in the same narrow band of years, tree ring cooling, volcanic sulfate peaks, and a cosmogenic isotope spike? That would point to a genuinely tangled disaster, the climate hammered from below by eruptions and from above by solar extremes, while human observers stand in the middle and describe it all as the heavens turned against us. And if the isotope record stays quiet while the skies in the stories burn red, then we're probably looking at more familiar physics, volcanic sunsets, dust veils, and the human tendency to reach for dragons when the light gets strange. So far we've mostly talked about things that go boom: eruptions, impacts, solar tantrums, fast cinematic disasters that give you a single bad year or a horrible decade, and then, at least in physical terms, move on. But there's another way to break a world. You don't need an explosion. You just need the rain to stop, not for a week, not for a season, for years, for decades, sometimes for whole human lifetimes. Climatologists call these episodes persistent drought regimes or climate regime shifts. They're not just a bit less rain. They're the atmosphere's large-scale circulation patterns getting stuck in a new configuration, redirecting entire storm tracks, weakening or strengthening monsoon systems, changing which parts of the ocean are bleeding heat into the air. To someone living through it, that doesn't feel like a new regime. It feels like the gods quietly closing the tap and walking away. In a monsoon world, this is existential. If you live in India, the Sahel, northern China, Mesoamerica, anywhere that has a strongly seasonal all-the-water-comes-now pattern, missing one monsoon is bad. 2 in a row is famine, 3 or 4. You're in civilizational collapse territory. What makes these slow disasters especially vicious is that they don't stay politely regional. The atmosphere is wired together by teleconnections, long-distance cause and effect chains that link weather on one side of the planet to weather on the other. The poster child is ENSO, the El Niño Southern Oscillation. In an El Niño phase, warm water piles up in the eastern and central tropical Pacific. That tweaks convection, which moves the jet streams, which shifts the big rain belts. The result, Peru and Ecuador can get hammered by floods, while Indonesia and parts of Australia bake in drought. East Africa can get wetter, the Indian monsoon can falter. North America's storm tracks wander, a single mode of ocean, atmosphere variability, one mood of the Pacific, and suddenly you've got some regions drowning while others starve under cloudless skies. That's the flood paradox. Ancient texts complaining that the heavens betrayed us in one region might be describing relentless river overflow and rotting fields. Another culture under the same global pattern is writing about the sky of brass, empty wells, people eating bark and leather. The underlying driver is one regime shift, but the surface experience is wildly different. So could a multi-decadal shift in ENSO-like behaviour, or in the strength and position of major monsoons, synchronise hardship across continents without any single spectacular boom event. There's a decent case. We know, for example, that the 4.2 kiloyear event around 2200 BCE lines up with aridification in the eastern Mediterranean, major Nile flow reductions, and stress in Mesopotamia and South Asia. Different regions report different symptoms: sandstorms, failing floods, abandoned irrigation works, but the common theme is simple: the water stopped behaving. This is where human storytelling does something subtle. With a volcano, people remember the day the sun vanished at noon, the week the ash fell. With a meteor, they remember the star that split the sky. With drought, there is no day. There's just another empty cloud bank. Another year the river doesn't quite make it to its old marks on the embankment. Another harvest a little worse than the last. Chronicles written during these times often don't start with fire from heaven. They start with bureaucratic details, tax remissions, emergency grain shipments, edicts about digging new wells, rationing water, moving populations. Only later, when people look back across a generation or two of misery, does it harden into a story of the years when heaven turned its face away, when the river forgot its path, when the rain covenant was broken. The slow disaster gets mythologized as a kind of drawn-out curse. From a scientific perspective, how do we even see these regime shifts, especially if they didn't come with a big sulfate spike in the ice? We go underground. One of the best archives are speleothems, stalagmites and stalactites growing in caves. As rainwater drips through soil and rock, it carries dissolved minerals and tiny chemical signals of the climate above. Year by year, those layers stack up. Changes in oxygen isotopes and trace elements can tell us when conditions got wetter or drier, when monsoon strength waxed or waned. In China, speleothem records track swings in the East Asian monsoon over thousands of years, sometimes lining up uncannily well with periods of dynastic crisis and migration. Then there are lake sediments. If a lake level drops during a mega-drought, wave-cut terraces are abandoned higher up the shore. The mud at the bottom shifts from fine, well-sorted layers to coarser, dustier deposits. Pollen grains change as wetlands dry and drought-tolerant plants take over. In places like East Africa and the American Southwest, lake cores show repeated episodes where water levels crashed and stayed low for decades. We also have direct human measurements, at least for the last few thousand years. Ancient Egyptian scribes carved Nile flood levels into rock. Medieval Chinese officials kept meticulous records of drought and flood years. In South Asia, temple inscriptions complain about 7 bad years of monsoon failure. Ottoman and Persian documents talk about caravan routes shifting as wells failed and oases shrank. Put these lines of evidence together, and you start seeing patterns. Multi-year, sometimes multi-decadal blocks where hydrology goes weird in several basins at once. Now drop yourself into that stitched-together planet. You're a farmer on the Nile watching the inundation come in ankle-deep instead of waist-deep, year after year. You're a merchant in southern India watching the monsoon winds arrive late and weak. You're a villager in the Levant seeing springs fail that your grandparents swore had never gone dry. No ash falls from the sky, no dragon auroras writhe overhead. But over 20 or 30 years your world constricts, harvest by harvest. People migrate, banditry rises, kingdoms argue over canals instead of border stones. When those stories finally crystallize into tradition, they may not say, once the Walker circulation reorganized and the Pacific Decadal oscillation flipped phase. They say, for many years the rains abandoned us, the river betrayed its people, the covenant between sky and earth was broken and nations fell. From our perspective, hunting for a single, same catastrophe across 4 continents, mega-droughts and monsoon failures offer a quieter hypothesis. No global ash veil, no crater, just the climate engine slipping into a mode where teleconnections line up badly for humans. Some regions soaked, others starved, all of them pushed far enough off normal that scribes and storytellers reached for apocalyptic language. The challenge is that slow disasters blur into background. They're harder to pin to a specific year, a specific layer in an ice core. But if we see speleothems, lake levels, and historical water records all bending in the same direction, across multiple regions over the same rough span of decades, we may be looking at another kind of shared catastrophe. Not one terrible day, a terrible pattern. And that raises an uncomfortable question for our mystery. Are we chasing one freak event, or are we staring at the fingerprints of a climate system that, every so often, simply decides to turn the screws on human societies for a very long time? Before we blame the sky, we have to blame ourselves. Because there's another, very human way to get the same catastrophe on 4 continents without a single shared physical cause. You don't need a global volcano. You just need a really good story and enough time. Stories move along the same channels as everything else valuable. Trade, war, religion, diplomacy. Anywhere people are forced to sit around waiting together in caravansary courtyards, on ships, at border forts, narrative leaks. Start with merchants. In the ancient world, long-distance traders weren't just moving tin and spices. They were your podcast feed. A caravan leaving the Levant for Mesopotamia carried rumours about kings, omens, strange signs in the heavens. By the time those same merchants reached Iran or India, they'd repeated the juiciest bits a dozen times, polishing them, exaggerating them, turning some local eclipse plus a bad harvest into the year the sun bled and the rivers ran backward. Missionaries and priests do the same thing, but on purpose. If you're trying to sell a god, you tell disaster stories that show that God winning or punishing or rescuing. Early Christian, Buddhist and Islamic networks all carried cosmological stories along with their doctrines. A monk fleeing a famine in one region doesn't just bring relics, he brings a narrative about why it happened, who was at fault, what the heavens were trying to say. Diplomats and scribes, they're professional copy-pastors. When a court envoy brings back a treaty or a royal chronicle from a neighbouring kingdom, he also brings back turns of phrase, stock omens, whole paragraphs of how to describe a really bad year. Those get translated, recopied, and welded onto local histories. And conquerors move stories at sword point. If an empire collapses after a strange red sun and 3 failed harvests, the refugees don't leave that behind. They drag it into the next valley, the next city, the next continent, until the years of darkness are no longer just one people's trauma. They're regional folklore. Over centuries, something else happens, scribal gravity. Writing in the pre-printing press world is expensive. So if you're a scribe, you steal. You lift a striking line from an older text. You reuse a standard formula your teacher used. You smooth out weird local details so the story fits the prestigious version everybody respects. Do that for a few hundred years and the metaphors start to lock in. The sun turned to blood. The stars did not appear. For 3 months day was as night. These become boilerplate for sky was wrong and everything sucked. Whether the original trigger was a volcano, a dust storm, a locust plague, or just a really bad imagination. This is how diffusion looks on the page. When historians suspect a story has travelled, they don't just go, hey, that's similar. They look for fingerprints. Exact or near exact phrasing turning up in texts from places that are known to be connected by trade or diplomacy. Identical sequences of motifs. Darkness, then famine, then civil strife. then a righteous king lined up like beads on the same narrative string. Translation quirks like a foreign god's name being half translated, or a metaphor that only makes sense in a different climate, sneaking into a new environment. If Egypt and Mesopotamia both say the river did not rise, that might be independent observation. If both say the river did not rise and the fish lay dead like offerings to the mute god of the underworld, and that weird underworld phrase only shows up in one language family first, you're not looking at coincidence. You're looking at borrow and adapt. Now contrast that with convergence. Humans everywhere see the same sky and have the same basic sensory toolkit. When daylight goes dim in the middle of the day, because of a dust veil, a firestorm, an eclipse, or just a wall of storm cloud, it's natural to say the sun died, or the sun was veiled, or the sun became like blood if it's glowing red through haze. You don't need a silk road to get the heavens turned away, as a metaphor for drought. You don't need missionaries to get the sea came in and ate the land after a tsunami. Put farmers anywhere on earth, hand them 30 years of weird weather, and you'll get curses about broken covenants between sky and soil. So the hard question isn't diffusion or convergence. It's whether we're seeing a hybrid, a real physical event or regime shift that hit many regions roughly together, and then, layered on top of it, centuries of narrative recycling through trade routes, pilgrim paths, imperial courts and scriptoria. Did one particularly dramatic catastrophe become the template that later scribes slapped onto other, smaller disasters? Did a poetic description of one dust veil ride merchant gossip and missionary sermons across half the old world, until it became the default way to talk about any wrong sky? To untangle that, we have to look at time, not just what stories say, but when they say it. And that gets messy fast, because ancient people didn't date things the way we do. Ancient writers weren't walking around with a little Gregorian timestamp floating over their heads. They weren't saying on June 7th, 535 CE at approximately 12 a.m. the sun went weird. They were saying things like, in the 12th year of King so-and-so when the barley failed, and there were omens in the heavens. Seems fine until you realize 3 problems. First, different cultures start their year 1 at different times. Second, they don't all agree on how long a year is. Third, later editors love to fix earlier timelines. Put all that together, and you can get 4 continents, 4 calendar systems, and 4 disasters that look like they line up or don't, depending on which scholar's spreadsheet you're using. Let's start with Regnal years, because they're everywhere. In a lot of ancient and medieval texts, time doesn't flow as a numbered sequence. It hops from reign to reign, year 5 of this king, year 23 of that dynasty, year 3 of the usurper no one likes to talk about. But year 5 of the king means nothing until you know when he actually started. Was his first year counted from his coronation, from the first new year after his coronation, from the death of the previous king, even if there was a messy civil war in between? Different scribal schools answer that differently. Some count accession years as year 0, others make them year 1. Some ignore short-lived kings altogether and quietly slide their months into the next reign. Now imagine you're a monk in the 9th century trying to reconstruct the 6th century from half-burned chronicles. You line up reigns using lists that are already copies of copies. You try to convert the year when the sun was darkened into your own calendar. You fudge missing months. You smooth gaps. You've just added up 30 tiny decisions that can produce a drift of 10 or 20 years. That's before we even touch the calendars themselves. Egypt is counting with a civil calendar of 365 days, no leap years. Over centuries, their new year slides through the seasons like a loose gear, slowly drifting away from the actual Nile flood. The Romans start with a lunar calendar that has to be patched with random leap months. Then Julius Caesar drops in the Julian reform, which fixes some things and breaks others. Local officials misapply the rules. Astronomers complain. Dates wobble. China is using a lunisolar calendar with intercalary months. Mesoamerican cultures have multiple overlapping cycles, a 260-day ritual count, 365-day vague year long counts ticking away in the background. Polynesian societies track years by star risings and seasons, not numbered dates. Everyone is keeping perfectly good time for their own purposes. The trouble only starts when we, centuries later, try to force all of those systems to speak in one voice. April 536, late 535, spring of 537. To get there, historians have to perform calendar algebra. They look at where festivals fall relative to harvests and solstices. They match the third month of spring to likely modern months. They trace when a king is mentioned in foreign records that use a different system. And in that translation work, certain errors show up again and again. Copying mistakes. A single misread numeral turns year 13 into year 3. In Roman numerals, a missing X is everything. In cuneiform, a worn wedge changes a 40 into a 4. One bored scribe, one blot of ink, and your carefully aligned darkness year just moved a decade. Chronicle compression. Scribes hate empty space, so they take 3 bad years and narratively squash them into one year of horror. Or they spread one spectacular famine across multiple entries because they know it lasted a long time, but they've lost the exact span. When you read it centuries later, it looks like either a single super event or a long era of lesser ones, depending on how you pass the text. Symbolic numbers. If you see 40 days or 3 years in an ancient text, treat it with suspicion. These aren't always measurements. They're labels that mean a complete period, a really long time, enough to matter. A 3-year darkness might be a few terrible seasons. A 7-year famine might be 5 or 9, or just a lot. So how do historians keep any of this from turning into numerology? They go hunting for anchors, hard, physical, cross-calendar anchors. Astronomical events are the gold standard. A total solar eclipse visible from a specific city, on a specific date, is like a cosmic timestamp. If a chronicle says, "In the year after the great darkness and famine, the sun was eaten at midday," and we can compute that eclipse to 538 CE, that entire passage suddenly has a grip point. Same with bright comets recorded over multiple cultures. The Chinese say a broom star appeared in the east in the 2nd month. A Byzantine source mentions a hairy star lingering in the heavens for 20 days in the same emperor's reign. Modern astronomy can back-calculate which comet that must have been, and when it was actually visible. Then there are volcanic horizons, those thin lines of ash or acid in ice cores and lake sediments. A particular sulfate spike in Greenland and Antarctica might be chemically matched to a known eruption. If a European chronicle says, "In the year of the darkened sun, we also saw frost in summer," and a New Zealand tree ring shows a cold snap at the same time as that sulfate layer, we can tentatively tie those observations to a real eruption date. Notice the word tentatively, because even with eclipse anchors and dust in ice, we're not usually nailing things down to the exact day and hour. We're building ranges like, this darkness report probably falls between 535 and 538. Or, these famine traditions could be describing the same cool decade. And this is where the timeline problem can trick us in 2 opposite directions. If we're too generous with our ranges, we can slide events around until they overlap. 3 separate regional disasters, a decade apart, start to look like one big global hit, simply because we've stacked all the error bars on top of each other. If we're too strict, insisting that real simultaneity must mean the exact same year or even season, we can miss a genuinely connected event that rolled out over a few years, hitting monsoon Asia in one summer, the Mediterranean in the next, and the Pacific a bit later. So the honest way to talk about this isn't on July 14th, the world went dark. It's more like multiple regions, using very different calendars and narrative habits, describe wrong skies, cold summers, and harvest failures within the same several-year window. We're not comparing diary entries. We're comparing windows of plausibility, which means before we decide that 4 continents saw the same catastrophe, we have to ask a quieter, more technical question. Do their windows really overlap in a way that demands one shared cause? Or are we just watching dates drift until unrelated tragedies happen to pile up on our modern timeline? To answer that, we have to leave the manuscripts for a moment and drill down into the actual physics written in ice and wood. So far, we've been wrestling with numbers and calendars. But there's another distortion we haven't touched yet. Even if you nailed every date perfectly, humans don't remember disasters the way they actually unfold. They remember them in the way that feels true. And across cultures, across centuries, that feeling tends to use the same vocabulary. Think about the phrases that keep repeating when we look at catastrophe texts. The sun was darkened, the waters rose, fire fell from heaven, the world was turned upside down. These aren't meteorologist notes, they're archetypes, cognitive shortcuts for things were no longer how they're supposed to be. Darkness is the easiest example. If you're living in a pre-electric world, your entire sense of safety and rhythm depends on the cycle of light and dark. Day is work, travel, social life. Night is danger, spirits, uncertainty. So when something goes badly wrong, a volcanic dust veil, a giant sandstorm, weeks of smoke from wildfires, even just a run of overcast cold days, it all gets pulled toward that same mental label. The day became like night. No one's out there measuring lux levels. They're noticing that noon feels wrong. Shadows are strange. Stars show up at the wrong time. The language reaches for the biggest violation it knows. The sun failed. Floods work the same way. Water doesn't just get higher than usual in most stories. It covers the mountains, swallows the land, reaches the sky, but real hydrology is messy. You get storm surges, river overflows, tsunamis, monsoon failures. Some places drown, others dry out. Yet across the world, when people tell flood stories, the details compress into an archetypal script. Too much water, too fast, in the wrong place. The scale inflates in the retelling until it feels like the entire world must have been underwater, because for the people living through it, their entire world was. Fire is the same category. Actual physics gives you lightning strikes, city fires, lava fountains, meteor airbursts, auroras, even weird refractions of sunlight at low angles. The brain doesn't catalogue those separately. It files them under the sky was on fire. You see this in texts that describe fiery rain, burning stones, the heavens opened in flames. It could be a meteor shower. It could be ash fall glowing in sunset light. It could be a city burning on the horizon. The language collapses all of that into one primal picture. Up there, where things are supposed to be stable, something was violently broken. And then you get the biggest archetype of all, the world turned upside down. On paper, that's useless as data. What does it mean? But psychologically it's laser precise. It means all the ordinary rules failed at once. Seasons came at the wrong times. Trusted leaders died. Food disappeared. Familiar landmarks vanished. Coastlines redrawn. Rivers changing course. Forests gone. So, whether you're describing political revolution, plague, drought, or an earthquake that literally tilts the land, the same phrase pops out. The world flipped. None of this is lying. It's compression. Traumatic memory is built that way. Under stress, your brain doesn't produce a careful chronological record. It grabs peaks. The moment you realised you were in danger, the worst sensation, the thing that symbolised the whole event. Later, when you tell the story, you strip away the noise. You smooth timelines. You make one terrible season stand in for 3 bad years. You merge multiple shocks into one. Psychologists call this narrative simplification. You also wrap the story in meaning. Was this punishment? A test? Proof you were the chosen survivors? Did the disaster start when people broke a taboo, abandoned an old god, stopped paying taxes to the temple? That's moral framing. In almost every culture, raw catastrophe gets very quickly welded to a lesson. The famine isn't just the crops failed for complex climatic reasons. It's, we turned away from X, so Y happened. This doesn't only show up in myths. It's in official chronicles too, and that's where politics walks in. What gets written down is almost never the full experience of the people who went hungry, or watched their homes wash away. It's the version that makes sense to the people who control the writing. A king facing crop failure might record a year of omens and rebellion, not a year my policies backfired horribly. A priestly class might emphasize portents in the sky and ritual lapses, not the fact that their irrigation canals silted up. A conquering dynasty might retroactively attach a previous regime's disasters to moral decay. In their final years, the sun refused its light, and the waters rose, for heaven had already withdrawn its mandate. Later copyists double down on those frames. They're copying what survived in the archives, not what your ancestor muttered around the fire. So you end up with a layered distortion. Real physical events filtered through traumatized memory, shaped into tidy moral narratives, curated by religious and political institutions, and then copied and reinterpreted for centuries. That's the mythic lens. It doesn't mean this is all made up. It means that by the time a volcanic haze or a freak storm or a run of bad harvests reaches us as text, it's been refracted through cosmology. If your culture thinks the cosmos is a tight moral feedback loop, where heaven immediately reacts to human behaviour, you will describe ash-darkened skies as divine anger. If your worldview is cyclical, ages of creation and destruction, you'll plug a weird cold decade into that cycle as the end of one world and the start of another. If your cosmology has dragons eating suns, giant birds beating their wings, or serpents holding back the sea, then eclipses, auroras, meteors, and tsunamis will be narrated as those beings stirring. Some of this is poetry. Some of it is the only explanatory framework people had. From our perspective, that mythic lens does 2 things at once. It can make totally unrelated disasters look eerily similar. A volcanic dust veil over Europe, a massive wildfire season in North America, and an El Niño failure of the monsoon in Asia might all get remembered as darkness at noon, failed crops. The gods withdrew their favour. But it can also allow genuinely connected events to echo each other with remarkable fidelity. If multiple cultures, with very different cosmologies, suddenly start reaching for the same rare symbolic vocabulary, 3 years without summer, the sun like blood, frost in harvest time, within overlapping windows, we should pay attention. So, when we see 4 continents describing wrong skies and upside-down seasons, we have to hold 2 thoughts at once. Yes, human psychology pushes us to reuse the same catastrophe language, smoothing jagged local experiences into neat archetypes. And also, those archetypes can still be triggered by one real shared physical insult to the planet. To find out which is happening in our case, we have to put the psychology next to the physics and see what story survives the comparison. So let's put everything on the table. We've got 3 recurring patterns that show up across continents. Wrong skies, wrong water, wrong food, darkened or blood-red suns, stars visible at the wrong time, halos, fiery rain, seas invading the land, rivers doing things they're not supposed to do, waters that forgot their bounds, and then harvests that fail, cold in the wrong months, famine, plagues that follow. Any scenario we take seriously has to speak to all 3. Not perfectly, but better than chance, and with as few ad hoc and also this random thing must have happened over here moves as possible. So what rises to the top? Model 1 is the boring, powerful one, a cluster of major volcanic eruptions spaced over a few years, colliding with a climate system already on edge. This is not fantasy. We've literally caught it in the act in the 6th century. Chroniclers talk about a year without sun, blood-coloured skies, bitter summers, failed harvests. Ice cores show a slab of sulfate dumped into the stratosphere in 536, another in 540–541. Tree rings across the northern hemisphere tighten. Cold, stressed growth. Food pattern, nailed. Sky pattern, nailed. Water, indirectly. Change the monsoon, weaken the Nile floods, shift storm tracks and rivers and coasts start misbehaving. Scale that dynamic up or down and you get a lot of explanatory power. Volcanic dust veils, darkened skies and reddened suns on continental scales. Aerosols, cool summers, short-circuit growing seasons, spike famine reports, knock monsoons and ITCZ belts around, and parts of the tropics drown while others dry out, feeding both waters' rose and rain's failed memories. Model 2 adds weather on steroids to that. Volcanic cluster plus regional extremes. Here the eruptions are the spark, but the fire runs through pre-existing vulnerabilities. Maybe a strong El Niño is already cooking in the Pacific. Maybe land use changes have primed certain coasts for massive erosion and flooding. The eruptions tip an already wobbly system. One region remembers it as a mega-drought, another as epic storms and coastal incursions, another as 3 summers of thin grain and pestilence. This mixed hazard model matches how climate actually behaves. You rarely get a neat, globally uniform disaster. You get a big forcing, then it cascades through regional quirks. That's how you can have Chinese records of frost in summer, Mediterranean complaints about dim suns and famine, and Pacific oral traditions about the sea running inland, all clustering in roughly the same window, but not telling the exact same weather story. Model 3 is the spectacle heavy option, a major cometary event or asteroid airburst, plus ordinary climate nonsense before and after. A bright comet or a Tunguska-scale airburst does certain things extremely well. It gives you literal fire from heaven. It produces terrifying sky displays, shockwaves, maybe localized tsunamis if it pops over ocean. The psychological impact is off the charts. Priests, kings, storytellers will remember that night forever, even if the broader climate response is modest. Tie that to a century where volcanism and monsoon instability are already causing crop failures and sea level weirdness, and memory glues everything together. The bad harvests, the sickness, the invading waters, all framed around that one unforgettable sky omen. Do we have a smoking gun crater or unequivocal geochemical fingerprint matching the legends we're interested in? Not yet. That's the main weight against putting this model in first place. Right now it fits the fire in the sky language and some tsunami traditions, but it doesn't automatically give you multi-year dimming and global cooling the way a volcanic cluster does. Model 4 is the slow burn option, mega-droughts and climate regime shifts, with no single sharp trigger. atmospheric circulation can reorganize, monsoons can fail for decades. The ITCZ can migrate. In some epochs we see continent-scale hydrological changes, lake levels crash, river courses jump, deltas drown slowly. That's perfect for waters forgot their place. 7 lean years, and the land cracked and gave no grain. But by itself, it struggles with the repeated language of sudden sky anomalies, suns that don't shine for months, stars at noon, repeated references to dust veils and smoke in the heavens. You can get haze from wildfires and dust storms, sure, but synchronizing that across 4 continents without some top-down forcing starts to require a lot of coincidence. So if we're ranking models just on explains the most with the fewest heroic assumptions, it looks something like this. Number 1, volcanic cluster plus regional extremes. Number 2, mixed hazard, volcanoes as backbone, with 1 or more dramatic sky events riding on top. Number 3, impact, comet first, with climate noise filled in around it. Number 4, slow climate regime shift alone, but even that ranking glosses over stubborn problems. There are flood legends with very deep time depth, tens of thousands of years, if the oral history estimates are right that clearly predate any candidate historic eruption. There are aurora like curtains of fire, described at latitudes where geomagnetic storms would have to be outrageous to match. There are drought memories in regions where the tree ring record doesn't yet show a corresponding mega-event. And there are texts that seem to insist on a single world-ending moment, while the proxy data tells a story of scattered blows over decades. On the flip side, some of the tightest cross-checks are hard to ignore. The 6th century dust veil case where written complaints about dim suns, late frosts and famine line up almost year for year with ice core sulfate spikes and tree ring minima. The apparent overlap between Andean oral histories of years when the stars were seen at day and evidence for volcanic aerosols in the southern hemisphere. Nile failure sequences that map eerily onto reconstructed monsoon weakenings. Pacific Sea came in accounts that match Paleo-Tsunami deposits dated to within a few centuries of each other. Those are the moments where the mythic lens and the physical record are staring at the same thing from different angles. What would actually move this debate from interesting puzzle to we're getting close? We'd need more precise clocks in the ice. High-resolution sulfate chemistry and tephra fingerprinting that can tie specific eruptions to specific years and then to specific texts. We'd need better dating of tsunami and storm surge deposits, especially along understudied coasts in Africa and the Americas, to see if those sea came in traditions cluster around 1 or 2 real waves, or a long smear of smaller events. We'd need systematic surveys of tree rings and cave speleothems in the tropics and southern hemisphere, where most of our high-res data is currently missing. That's where monsoon failures and weird flood regimes would write their signatures. On the cultural side, we'd need more ruthless philology, lining up versions of the same myth in the same language over centuries, to see how much has been added or shaved off. That can tell us whether a single Great Darkness narrative is actually a later compression of multiple bad years, and hanging over everything there's a wild card, new impact evidence. A securely dated crater, spheroidal layer, or shocked quartz bed that lands right on top of a cluster of fire from heaven. Seas ran backward. 2 winters in 1 year traditions would shuffle the rankings overnight. Until then, the best we can do is this kind of synthesis. Put sky, water and food stories next to ash, ice and rings. Let them argue with each other and see which combinations require the fewest miracles to connect 4 continents that all insist the world went wrong at once. So where does that leave us? We set out with a suspicious pattern. 4 continents, eerily similar disaster stories. We tried very hard not to do the easy thing, pick a favourite narrative, hammer every source flat, and then declare the mystery solved. Instead, We treated it like a crime scene that's been rained on for centuries. We compared the sky language. When do texts talk about noonday darkness, veiled sun, blood-red moon, stars in daytime? Are those one-night omens or multi-month atmospheric weirdness? We compared the water language. Are we hearing about slow-rising seas and drowned river mouths, or sudden walls of water and waves taller than trees? We compared the food language. Are there tight sequences, 2 summers of thin grain, then pestilence, then revolt, that we can put next to tree rings and ice cores? And we tried to line them up against the only clocks that don't care about human drama: volcanic sulfate layers, growth rings, sediment stacks. When we did that, some alignments almost snapped into place by themselves. Mid-6th century, grumpy monks and bureaucrats from Ireland to China complaining about dim suns and failed harvests, while ice in Greenland and Antarctica quietly records a twin punch of sulfate. Tree rings whisper cold, short summers. Here, the written word and the frozen chemistry are practically finishing each other's sentences. In the Pacific, sea came in stories, hug coastlines, where we actually find tsunami deposits. In a few cases, the approximate dates from oral timelines land in the same millennium as the sand sheets. In the Nile basin, chronicles about years when the river forgot its duty track roughly with reconstructed monsoon weakenings. Not exact year-for-year matches, but enough that it feels like we're hearing distant echoes of the same atmospheric mood swing. But then there are the gaps that just sit there and stare back at us. Flood legends that may reach back tens of thousands of years, far beyond any eruption we've pinned down, yet told with such geographic precision that they sound like real coastlines, real river mouths. Descriptions of aurora like curtains of fire at latitudes where you'd need solar tantrums way beyond anything in the modern record. Drought and famine memories in places where, so far, our tree ring data doesn't show an obvious mega-event, either because the event wasn't global or because the proxies we've drilled just haven't captured it yet. And always this tension. Some traditions insist on a single world-ending night or year when everything broke. The geophysics so far keeps offering us clusters, sequences, chains of bad luck, spread out over decades. So the question hanging over all of this might actually be bigger than, was there one huge catastrophe everyone saw? It might be. Are we looking for the wrong kind of answer? Maybe there was a standout year, a 536 style dust veil, a rogue comet, a monster eruption that stitched itself into memory across half the planet. That's still on the table, maybe. Instead, there was a whole century of mostly bad with occasional horrific, bubbling with eruptions, monsoon failures, tsunamis and famines, and different cultures compressed that long grind into a single mythic event. Or maybe the real constant isn't the disaster at all. Maybe it's us, put human beings under severe, repeated stress, and our pattern-making minds reach for the same story structures. The sky goes wrong, the waters cross their lines, the food disappears, the old world dies, a remnant survives. Whether the trigger is a volcano, an airburst, a mega-drought, or all three, the narrative shell ends up looking strangely familiar from Peru to Mesopotamia. In that sense, these same catastrophe stories might be less like synchronized news reports of one night, and more like independent attempts to explain what it feels like when your entire system, climate, economy, cosmology, falls apart at once. That doesn't make the physical events less real. If anything, it makes them more urgent. Because the mechanisms we've been talking about, volcanic clusters, climate shifts, freak solar storms, impacts that don't quite miss, are still part of the universe we live in. The 6th century isn't some sealed-off mythic age. It's a dress rehearsal. So I'll turn it over to you. Do you think we're circling one lost global event? A chain of regionally different but psychologically similar disasters? or a deep shared pattern in how humans tell stories when the world breaks? Drop your thoughts in the comments. And while you're there, tell me where you're listening from and what time it is for you right now. I love seeing the spread, midnight in Manila stacked next to breakfast in Berlin, an afternoon commute in Sao Paulo next to a 3 a.m. insomnia watch in Nairobi. If this kind of long-form, cross-disciplinary rabbit hole is your thing, make sure you hit like, leave a comment and subscribe so you don't miss the next one. And if you want to really support the channel, the best way is actually just listening. We're on Spotify, link is down in the description. Throw an episode on while you're commuting, cooking, doom-scrolling, whatever you do. It helps more than you'd think, and it keeps this kind of deep dive content possible. So one event, many events, or one very human way of seeing the end of the world, you tell me?